on being observed. So without an observer, there is no horizon. As soon as you close your eyes, the horizon is gone. As soon as you close the window, the horizon is gone. It relies the necessary antecedent. Let's say it this way: the necessary antecedent for a horizon is the observer.
Is that the same for horizontal?
No.
Wouldn't it always be being perceived by something?
But that would be different horizons, and no, not necessarily, because some people might not be looking at the horizon. Like you're assuming that everyone, like at some point, there's going to be at least one person looking at a horizon, and then you're equating all horizons, when they're going to be different.
Can you
Yeah,
explain what you mean about
I understand what you're saying.
Can you explain what you mean that all horizons need to be observed?
Well, I mean, can you have a horizon that you're not observing?
I think so.
How?
I don't know. I think so. I don't know.
You could have a horizon that somebody else is observing, couldn't you?
That's what he was saying. That's what I was getting into. But what I understand what he was saying, so that's why I wanted to elaborate, because he made me understand. So he's saying, although there's so many people on Earth, not everyone's going to be looking at a horizon. Although there will always be someone looking to the horizon, there will be parts of the horizon that they're not being observed. I live between two mountains. I can't even see the horizon. My horizon is the top edge of the mountain. You know what I mean?
Horizon.
Versus somebody my topographical horizon, versus if I went up and got on the mountain,
right?
I still technically have a horizon that I observe. I do, but it is not.
Well, is it actually a horizon if it's topographical?
Yeah,
I don't know.
Topographical horizon. Yeah, of course it is.
I don't know, because technically it's where the sky meets the ground, right? That's my horizon.
See, that's why they call the actual one a true horizon.
The true horizon, wouldn't that be looking over sea level?
Over water, yeah.
Yeah, it would be looking over a flat body of water.
Does it have to be water? What if it's flat land?
Well, it depends on how flat it is, and if you can test like the topography.
Does it have to be flat?
I
don't think it has to necessarily be perfectly flat either, yeah.
But think about it. Mountains would look flat if you were far away enough. If you were high enough up, like mountains would look flat.
But you could just not look at them. Couldn't you, like Percentage was saying?
I like this guy.
Well, the mountains, if you're far away enough, you wouldn't see them, right? If they're far away enough, then they'll converge into the horizon, and they wouldn't be mountains anymore.
Or the horizon would be above them, like they would be below the horizon.
Sure, yeah, and peeking out from behind.
It would still
I have
be
a couple photos
horizon as well, wouldn't it?
Of zero? I don't. It would. I don't know. It depends on.
Could you call a topographic horizon flat?
No.
I don't think anyone would.
Because looking at my topographic horizon, which would be looking at an upward angle towards the sky, because I literally live at the base of a mountain, at the base of two mountains. I live in a fucking ass crack valley. So my horizon shifts so much, it is not flat whatsoever. It's the shape of the top of the mountain. It's the last part of the sky that I see before it touches the ground. It's not touching the ground.
So
it goes beyond that. I just can't see. No.
Well, technically, topography just means measuring, like, the surface, right? So if you're over flat water, then the topographical horizon is the true horizon.
It's like if you wanted to take a measurement of a mountain.
Yeah, there's topography. It's just all even.
There is topography, but the topography stops it from being flat, apparently.
What?
Why?
On land.
On land, but water topography it's level. It's level. Literally level. Flat level. It is not plumbed. It's level.
How do we know whether we're talking about the topography that isn't flat or the topography
Okay, so
flat?
here, let me put it this way. If you're if you measure with an inch, let's say you want to measure the length of the ocean with an inch long measuring tool. You measure it inch by inch. That you are going to come out with a measurement hundreds, if not thousands of miles longer than if you used a measuring stick that was 1 mile long. Because with a 1 inch, you're measuring every single little curve of every little inch, literally every inch of the water, the curves, everything, all the little topographies, right? But if you take the vast amount of water over a gray area, a mile, or really anything over like anything over 200 feet, it's going to be considered flat.
What are you talking
Unless
about?
you
You do the
got-
same thing, and then with the waves, like the crests.
That's
and
what
the
I'm
troughs of the
saying.
waves.
That's what I'm saying is like the little, like if you use an inch ruler to measure
Would that be the
a
same as the
wave,
land then?
no.
No.
Well, yes, it would be because
Would
you
It
can
would
take
be.
a
Would you
if you
measure-
had a 10 foot
brilliant.
if you had a
I like
10
it.
foot long pole and you used it to measure a mountain, your measurement would come out, let's say 1,000 feet, 500 feet up, 500 feet down. But then let's say you use another 1 inch measuring stick, you're going to come out with like 2,200 feet because you measured every inch
Is that
of
a bigger
every
distance?
rock all the way up, left, right, up, down, at
Well, can
every
we just
angle,
nip this
not just
because this topic isn't really. Yes, if we were to measure the topography instead of just a straight line distance, it would be a higher value. We agree on that. Can we just move forward because I feel like it's not
Yeah,
really.
but isn't
like,
he saying that you
worth
can
exploring.
measure the topography
Wait, I
flat?
have a question. I have a question.
No, topography
over a
is
great
only
enough
flat if it's
distance,
true
it's
horizon.
flat.
Nathan Oakley. When
Wait, I have
Nathan
a
Oakley
question.
comes around, keep that one in mind.
Let's
Wait, I
say
have a
you
question.
have this ocean that just froze over and it's perfectly level, right? There's no waves. Would be flat. It just means measuring the surface or the place, right? So it could be measured evenly. Right?
Would that be a measured flat topography, like this man was just talking about?
Yes, it would be
If
measured
there's no waves, it's just
absolutely
frozen,
flat
it's
level.
perfectly even, then yes, it would be.
With an inch ruler.
So
But
is
it never
the,
happens. Because I don't think even the oceans freeze over, so good luck with that.
Wait, so
This is it.
wait, here, I have a question. How can the Earth be flat? So, like, look, if you look at every other thing in the universe, it's all circle because the gravitation pull is in the middle.
Are
of it.
circles globes?
Well, yeah, they can be.
Can you have flat
Is
circles?
it the-
Universe.
is it the zoom
Thanks for
tool?
coming, bro. Thanks for coming.
Well, but I
We
mean,
don't
like,
observe-
they're not stretched out.
It's
I mean, they're not
multiverse.
stretched out. I mean,
We
they're
don't
not
Is it the
stretched
zoom
observe.
tool
We
that's
don't
the,
observe spheres. We observe circles. We observe two-faced objects. We have no observation of a sphere whatsoever.
Okay, so
But
like,
if
you're
you
telling
use
me,
a zoom
You meant
tool-
two-dimensional
Take a
objects,
walk-
not two-faced.
if you take a walk across the Earth, you're just gonna like randomly find a little piece that comes off the side of the Earth and just have to walk down it and just come like on the other side of the Earth, like below it.
if we
Like,
use a
I don't
zoom
know if that
tool, it
makes sense.
disappears.
So it just disappears. So how
With
is
no
this a sense?
topography. If you use the zoom tool, then you're fine. No topography then.
Inch
Okay,
ruler.
so
You mean? An inch ruler.
okay, so then how can I walk around the Earth and just come
Because
back
last
to the
time
same
I went
spot?
to the beach, there were some waves up and down, up and down. Definitely topography.
So if you start, let's say, on the equator and you walk directly north, you can make it to the North Pole. The second you get to the North Pole, heading in the
No, you
same
can't.
direction, listen. I'm not saying you physically, literally can because you're not walking through water and all that stuff.
Why
But if
ask
you
us to do
beeline
it?
it
Got you.
to the North Pole and you get to
Well,
the
of
North Pole,
course
you're
it's gonna be
heading
flat.
direct. Listen, I'm not. Hold on. I don't even
Just
think you
finish
know
your
what I'm
thought,
trying
finish
to
your thought, bro.
express. You go directly north from the equator, get to the North Pole. The second you pass the North Pole, heading in the same direction, you will be going south. Go south as much as you want.
North to south.
You're not gonna make it any
You can
further
travel in
south
one
than the South
direction
Pole.
and then find
That's
your
the
goal
edge.
in the
That's
opposite
like
direction.
you can try it, but good luck. Tell me what you see when you get there. But you can travel east and west around as much as you want, and you will have to turn to compensate east and west. You will. That's the
Sound like
easiest
you've
way to
thought
explain
about
it.
this.
You won't knowingly do it though.
You can fly south only a certain amount of time. You can fly north only a certain amount of time before you're going south. You'll never go north from going south, but you'll always go south from going north. You can always reach back to your destination from flying directly east or directly west. If you try to fly directly east in a straight line, you cannot. It'll always change to southeast. You have to compensate and turn left to keep going east. Same thing for going west.
You a pilot?
No, well, I mean, you're accurate up until the very last part. The very last part, you don't actually have to turn left because you're following a heading and you're doing micro turns that you're unaware of.
You're not unaware
Why
of
some
them.
stupid
You
meters?
you should be aware of them because you're going to notice that you're going south, like what would it be, southeast east, and then you would adjust back to go east instead of going. You would notice the
No, because
adjustments that
anyone
you're
who
making.
flies, they have a heading. They follow a bearing.
Okay,
They're not
okay,
gonna
that's
be
what I'm.
flying
Okay,
as
that's
the
I'm
crow
saying. If
flies.
you're flying directly east, I know they fly from destination, from destination, or what would it be? Not destination. They fly in a straight path, right? They're
Heading
not
to
gonna
heading.
fly around. There would be no point to make a big ass curve. They fly from point A to point B directly. But I'm saying if you wanted to fly directly east, you would have to keep making small adjustments to stay on your east path.
Yeah, I agree.
But if you fly
all the way
directly north, you do not have to divert whatsoever. You can stay straight north until you hit the North Pole. You'll be flying directly south. That's the easiest way I can try to explain it.
What's the North Pole?
The North Pole, I don't know.
Like, are you talking about geographic? Or are you talking about magnetic?
It would be magnetic if you're flying based on a compass. It would be magnetic north. Which is what
Okay,
I was
so then-
expressing in that example.
Okay, so only if you're like fortunate enough to be perfectly in line with this magnetic North Pole will it, and it won't go instantly south, mind you. It'll go one way or the other towards east or west, depending on how big the North Pole is. It might, let's say, the magnetic North Pole is like, 15 square miles or something like that.
Okay.
The compass is slowly going to go east or west until it goes south after you traverse it, right?
Yeah, you would see your compass flip. It would definitely, depending on if you're slightly to the left or slightly to the right, the north point of your compass would drift one way or the other at an exponential rate until it reached the what is it, the vertex, the highest point of speed. And then it would slow back down as you leave it until you're flying directly south.
Go north until you go south.
Unless you fly directly over it and you're fortunate enough to like fucking center point it, and then your compass will just quickly do a 180.
go
but
south and then go
I'm not trying to
north?
get
So
into
brakes- compass with
specifics
brakes,
like
man.
that. It doesn't matter either way. You fly north far enough, you're gonna end up going south.
And can you fly south far enough to end up going north?
No, I already said that.
Oh.
No,
Well, it's a one-way thing then.
it's a one-way thing, man. You
Right.
can fly. You can
All
fly from.
directions
I'll put it this
equal
way: you can
south.
fly across. You can fly across the what is it? The diameter. You can fly the radius to the center, but you cannot fly around from
Radius.
north to south
Did you
back
measure
to
that?
north.
I think Nathan Oakley said
The-
that had been measured.
The radius, you
Yeah.
can measure the radius. Yeah, you can just pull up a map that has all of the here.
How come you can?
I can get you the radius right now. Radius, it would be the radius is the distance from one equator on one side of the North Pole to the other equator on the other side. And the reason I'm going to give that as a distance reference is because I don't think that there's going to be an exact distance reference from an average point of Antarctica to magnetic north.
It's a straight line distance, though, right?
I know,
No,
yes,
that's not-
I'm
it's
going
not technically a
straight
radius.
line.
Brilliant. Brilliant.
So
Okay,
diameter.
but radius, I know. So
Nathan
what I'm
Oakley
saying
will
is,
be
yes,
well
it's
impressed when
technically
he
not
comes here.
radius, but based
You
off
charge
the laterals
Nathan
that we're
rent to
giving.
live in your head.
No, he's coming
Yeah.
here, mate. Have you
No,
got?
he lives rent free.
Have you got the person, the chaperone, the one who's gonna aid him to come over here?
But yeah, Frothy, I wouldn't call it a radius. I would call it just a equator to equator measurement or something. Equator north, equator measurement.
Instead of
come you
equator
can,
to equator, I will get an average Antarctic to magnetic north measurement.
That'd be
how
cool.
come you can fly north and go south, but not fly south and go north?
Because you can fly over the North Pole, but you can't. It's okay. You aren't able to, I guess, legally,
allowed.
off of the Antarctic Treaty, you are not legally allowed to go past, which is south. You're not able to maneuver
not
your
allows
way
you there.
south past. Yes, because there's over like fucking who knows how many countries on the Antarctic
You
Treaty
can't go
since
south
way
to go
back when.
north because the
Past the
government.
80th lateral, that's the furthest that public can go. There's
It's
certain
60th
like
parallel, 60th.
is it the
But didn't
60th you're not
the
allowed? I'm pretty sure it was the
Yeah,
80th
60th
that you're not
parallel.
allowed.
Okay.
but didn't
You're not allowed
didn't
to.
Soviet Union fly over across Antarctic?
You can fly over Antarctica, yes, but you're not flying directly south. You're not flying over the like it's not a center to fly over. You're flying over ice and you have to decide if you're going to be flying east or west. You don't get to choose
Why?
to keep flying south because you will not it is the earth is flat. You will not wrap back around. If the distance keeps going, it keeps going. I have no idea if there is or what is if there is beyond Antarctica. Okay, like Antarctica is a massive landmass that surrounds
Couldn't
the
you say the
entirety of
same?
the earth that we know of, the earth that we live in. Okay, so now
Then could you say
when
the same thing about
I don't. I'm not here
the
to get
north?
into
I don't know that.
hypothetical
How do you know that?
conversation. I'm not here to
No, I
get into
know. I'm just
hypothetical
saying.
conversation about what's
I
beyond the
know.
ice wall and
Yeah,
all
I
that
know.
because I definitely can and I can go into all that stuff, but that's unproved. That's stuff that
Yeah,
hasn't.
is
I'm
this?
not going to bring it up. That's crazy talk as of now. Like that's conspiracy talk. What we know as flat earthers and the things that have
You
made
know
us
that?
believe what
Wait, you
we
know that?
know. No, I'm
Yeah,
I don't
saying
know
what
that.
we know.
confidence.
As,
That's the way to
what
go
we
forward.
know as flat earthers. What changed your mind to believe it? Any of you, if you truly do believe it, those reasons should
Bro,
be
what are you
good enough
saying?
to change anyone's mind.
I was
Okay,
questioning
so
Nathan Oakley
so
with the
don't.
Earth is measured flat, but you seem to have
Bro.
validated it for me. I think I might be coming
You don't.
over.
I'm not trying to I'm not trying to listen. I'm not here to You
You
have
said
your
the
views. I
radius
have
was
my
measured.
views.
Can you not remember? Nathan
Yeah.
Oakley's been asking for it
Yeah.
for ages.
Yes.
So this new confident approach seems to have
I'm
reaped
sorry.
rewards.
It's the measurement, the radius of the average Antarctic. So it would be from the North Pole to essentially the furthest south point we can go, which is Antarctica. So it's
A
roughly
straight line.
12,400 miles in a straight line. 12,400 miles.
Couldn't you say the same thing about the Antarctica then? What you said about the North Pole?
Yeah, why are you trusting that, Frothy?
Why am I trusting what?
The measurement
Confidence.
they gave.
I'm sorry, I have to hear what you asked again.
The measurement the heliocentrists, like the modern glober.
Because
those-
it's based off of the parallels, and the parallels of the heliocentric model do correspond with the what would it be, the new map of the world model. So the flat earth model parallels correspond almost
can I just say
exactly.
something? Don't attribute the parallels to the heliocentric model. Okay, the celestial sphere existed before heliocentrism. All right, this idea that like longitude, latitude, celestial sphere from the stars in the sky and stuff like that, it predates the heliocentric model, and it's not
Yes.
it's something that they took on. So don't attribute it to them because they don't deserve it. But how that's just that's basically lines in the sky that we've kind of we've imagined from based off of star cycles and what have you. Where have you actually done a a ground-based.
That's going to be the lasting impression I leave that, which
like
for most people is
quantify.
But most people aren't that committed to the globe, believe it or not. When you go out into normie society and start
I
talking
personally
about this,
have not.
get a few
I go
raised eyebrows,
based
don't
off
get me wrong.
of.
Most people are
I go based
intrigued.
off of the fact that not only is like I get a lot of
Just wait a second.
false
Number one,
information
welcome
is
to
given out by people that give out factual information as well. So to decipher what is factual and what is false, you have to
I
look
did
at
hear
other
that.
sources.
Yeah,
So
I
if
heard that.
private
Fact, yes.
sources or
Yeah,
other
so
public sources come up with the
when
exact
he
same
was-
measurements for the parallels, all of this stuff, people who
Yeah,
aren't
Darren in
in
the
or
background.
are part of treaties or anything, like they come out with the same measurements. So I think it's
How
safe
do you
to
know? Have you ever
say that
seen someone do
measuring
the
the South
measurements?
Pole from the 90th
Earlier when you and Brian were talking
that's what
about,
I'm saying. I have not,
leading
but
off
based on the
with, we
information
treat the
that
Earth
almost
as
every
flat.
single
It
person's
made me think of something
measurements
that I
add
heard in another
up, and I'm
forum the
not
other
saying
day.
just major, I'm also saying like private scientists, like private people, private investigators who look into this information, who have much more money than I ever will and I ever
Father,
could to
hear me
go
out for a
out.
second.
Engage in
Hear
debate
me
on
out.
the subject.
What you're doing is
And
it's
I've
called
qualified
appealing
what my statement
to the
previously by
majority,
saying then
argumentum
you
ad
need to
populum.
visit
You're saying
these
because
shows,
of
you need to
they're
really
all
educate
agreeing on this,
yourself
then
on
it must be
the
true. But you
essentials
don't have
so
any
that you
actual evidence. You don't have video of them measuring it or anything like that. So I'm just saying, I
can
would be wary
argue
of
the
making the
toss.
claim that they've
As an
actually
attitude for
measured
us
it,
as flat
right?
earthers
If you're
moving
claiming that
forward,
this is
we've
the
had
this is
10
the claimed
years
measurement, sure.
of
But to say that they actually
convincing
measured it,
ourselves that the
I would
Earth
be
is flat
I would
by
be
way
wary
of
of that. I'd
belief.
say be skeptical until you have the evidence, and then if you have the evidence, then make the claim. Because you're
I
going out on a
think that I'm
lens.
past skepticism with it
No, and you're
because
saying that they
based off
actually
of
did
like
measurement without the
naval
evidence.
navigation, those are what are used. Like those are the measurements that they use to get to exact points around the world.
Do you know how do they measure accurately over water? You're talking about naval measurements. How do they measure accurately?
I don't know, but I do know that they use the measurements of the parallels. I know that they use longitude and latitude.
Yeah, but longitude and latitude, that depends on whether the Earth is the topography of Earth and stuff like that. If there's a lot of topography, you could have this like in the same longitude latitude, you can measure a higher distance, just like you said with the inch
Measure it with
thing.
an inch.
If you're measuring all of the things,
things.
yeah. So, and then not to mention over water, you have currents, you have winds, you have crosswinds.
They're definitely measuring by sight.
Headwinds
They're
and
not
tailwinds.
measuring with a ruler. How
you have a tailwind that's making you move faster, so you'll measure the ground to be shorter if you're measuring it that way. So like
Hold
you
on.
have to.
So what? I think what they
Go ahead.
will do, right, is they will measure an elevation angle change, right, of a distance over land, right, which they can pretty much measure the distance over land pretty accurately, right?
With an inch ruler.
And then they can
preferably.
do right.
Yeah, how are they measuring the
Yeah.
land?
And then they will apply that while they're at sea. So a change in elevation angle measurement to a celestial object, right, will indicate that they've traveled approximately similar amount of distance, right?
No, he's measured it. He's already said he's measured it. I don't know whether he did it with the inch ruler or the other one, but he's got the radius.
Zoom function.
I was being
Listen, I'm
serious
taking
earlier
numbers
about
from a
bringing
general
Nathan Oakley
consensus,
coming over
and
here.
I was trying to put in perspective, not make a joke about an inch ruler being used to measure. I was giving you an example showing that a smaller measuring object can measure greater distances over a small area.
Have you got a
Can I
garden?
respond really quickly to the person that said you get the angle measurement to the the altitude of a star or what have you, and then you transpose it onto the water? The question is, how do you measure the land in the first place accurately? This land that has topography, how do you get the straight line distance? How do you cut through all the topography and get the accurate distance?
Yeah, you're not going to. It's going to be
Triangulation.
triangulation, but it's going to be an estimate at best anyway. Like it's not going to be
Triangulation isn't an estimate; it's mathematical. It's exact.
Well, it depends on how many reference frames you have, because it depends. If you're going based off of one star, it's not going to be accurate.
Can you elaborate on triangulation? How you're going to get an accurate measurement with triangulation?
Yeah, straight line distances.
What are you measuring though?
You're measuring. You measure your baseline, and then you use the properties of triangles to be able to measure the land. you know, like maps and stuff.
Can you give us an example? Can you run us through like a simple measurement? I'm not getting
measurement of distance.
Yeah. Yeah, whatever you mean in terms of like an accurate measurement with triangulation.
I'm surprised that you don't know. Have you ever heard of trig points? Like they
Let's say I
have on
haven't.
the
Go
land,
ahead.
right? Where they place theodolites up on like mountains and stuff, and they're normally up at high. Yeah, well,
Okay.
because you started off your survey or your surveying thing with an accurate measurement of a baseline. So what they do with that is they start off with a distance that they are absolutely certain is straight and at the same elevation. And that
How do they get
becomes
that?
your How do they get that? By measuring it. Precisely.
They measured an absolutely straight piece of land.
Absolutely straight. Yeah, it has to be. This is the most precise
Like with
thing
the water
you
level?
have to do within measuring. Yeah.
With the water level type thing?
Well, just in order to make it straight and precisely straight, you have to measure it as straight with checks, balances to make sure it's precisely straight.
So did they level it out if it wasn't straight?
It's at the same elevation. It's a straight line.
I know, but
you need to know the straight line distance precisely.
Okay, hear me out. Hear me out. When I got my flooring done in the house, they measured it, and you know they wanted it to be completely level, right? So they used some leveling liquid to make sure that it was level, right? So my question is, with this base station or whatever it is,
they use
baseline,
leveling
did they level it out with like a water level? Did they like where it wasn't level, or if it was what?
They use self-leveler.
Okay, so they leveled it out. All right, so now you have this level baseline, and then go ahead.
What you do is they mix that stuff and they just pour it on. It's called
Are you taking the piss?
Self-leveler, right? It does what it does itself using the properties.
Are you saying that's what they did at the baseline?
No, they measured it precisely. Like they do.
So they measured it and it just happened to be precisely flat.
Surveys or anything on any new land. Step one, measure baseline precisely. Because everything else is going to depend on it. Everything else.
But with topography, it's very, very rare that you have a perfectly like level piece of land. So are they leveling it out or not?
They're precisely measuring it at an equal elevation. Yes. To make sure it's straight.
So they put one on
upon that straightness.
So you're telling me they put
triangulation, trigonometry.
Okay, let's say I'm on a plateau, all right, and this plateau has very, very slight hills. It's not perfectly level, and I want to make my baseline there. I measured it, and it has very, very slight hills and dips. Right? What do I do now to make it my baseline?
You'd be better off starting at the best place to do your baseline, wouldn't you? That would be the ideal place, because
so you're saying they find a perfectly piece of level land.
It's difficult to be able to do it, and you need a bit of land where you are able to measure this baseline to start off with. Right, it's precise.
And it was naturally...
You need to use the use of triangles, and triangles have certain properties that means you can predict an other length, let's say, through the use of the angles and the proportions of the lines and the sizes and all that sort of stuff. Right? We know this about geometry. And so in order for us to start off our base of measurement, we need a precise, straight line.
Yeah, but how are you making sure it's precise? Like, are they filling it in for like the micro deviations of the topography? Or are you saying that like 1 in a million chance they find perfectly straight land?
They're just measuring a straight line.
Oh my goodness.
Uses the unit that they can then use so they can proportion all of the other lines and angles and stuff that they can map together to make the map, to put the positions on the map.
I tried. I tried asking it like
Oh
so many
no,
times.
Okay, no, he's wrong.
it
I'm
is.
reading it. He's explaining it wrong. So what it's saying is it's not a straight line. They're placed in at different heights. It depends because you can't always have the same height area or dig down to it or whatever. And it says right here, surveying instruments that measure the horizontal and vertical angles. So then they do calculations based on the elevation, the exact elevation of the pillars, which it says they're all grounded like heavily with either rocks or pillars that are like way bigger than
You're
them.
going to need to know a
So
distance
Yeah, well, to be fair,
first.
he
so
didn't
they're
say.
You need to know
stationary.
the
So you
distance of
have
one of your
to
lines, right?
here's the thing. Here's the thing. People have their ways of measuring. They some way, shape, or form.
Baseline.
Then now
Establish
they
baseline.
measured the altitude of where they were putting them to the
Frog, you're
exact
skipping a
right.
step. You're skipping step one, which is
Why?
measuring the
Why?
baseline.
Why?
Dude,
They
Please read
do have
how
a
they measure the
baseline. I'm
baseline,
sorry. Yeah,
how
the
they
points
get a
are built
straight
so it's
baseline. Read
we
that.
need a distance.
If you use a false dichotomy modus tollens, measuring that straight line can disprove Bob's Earth sphere.
One at a time, please,
Nathan
gentlemen.
Oakley
Please
didn't
continue.
really want to any of that, though. But I mean, yeah, this is the
Oh my God,
baseline that
I
we're
know
Why are you
him.
name dropping
He's
Santa's
so
not
much,
here.
coming
man?
to
He's not here,
town.
Bev.
Santa's coming to town.
Yeah, he's not here, Bev. We don't need to worry about him at the moment.
Oh yeah.
Well, yeah, okay. Nathan Oakley's not here, right? Doesn't matter. But
Santa's
do you
coming to
think?
town.
Do you think this measuring this straight line is a proof of the flat Earth?
Yeah, mate.
I think you can't measure something
Of
unless
course
it exists. So you have to make a physical straight line first, or find one in nature. Which is good luck with that.
Find a straight line in nature. Shortest distance.
In terms of the
between
ground,
two
yeah, you're
points.
saying baseline from a total station, that the ground would have to be. You're saying is perfectly level, right? Good luck finding perfectly level. How big is this
straight
baseline? by the way?
line needs to be a horizontal distance. It has to be. Because that's the shortest distance from A to B. That's what you're going to base your entire measurement structure upon. That straight line and the distance that you measure. So you best make sure that it's the shortest distance.
Will that be the ground?
Dude, if it isn't horizontal, then the distance would be longer. Do you understand?
Is the line you're using, is it the ground?
If not horizontal, then longer distance. It becomes the hypotenuse. The distance you're measuring, if it's not along the horizontal, it becomes a hypotenuse. And you know that because what I'm talking about is geometric.
Yeah, but he wants to make another fucking point that the Earth's not. Oh, the Earth's flat, but he's not going to fucking prove it right because it's bullshit.
What is your line? What is your line, Bev? What is the line? Is it?
It's the shortest distance.
Yeah, okay, so you're measuring a distance of what? Of what? What are you measuring the distance of?
The shortest distance between those 2 points. It's called your baseline. It's what you need to
Something
use
you walk along
for the structure of the rest of your geometry that you're going to do.
Can you walk on
measurement.
it?
Yeah, it's called the planet Earth, bro. There's multi-dimensionals too.
Yeah, well, the straight line disproves Bob's modus ponens, doesn't it?
It says trig points are used by Ordnance Survey in order to determine the exact shape of a country. They're generally located on the highest bit of ground in the area so that there's a direct line of sight from one to the next. By sitting a theodolite or a accurate protractor built into a telescope on the top of a pillar, accurate angles between pairs of nearby trig points could be measured. The process is called triangulation. So it doesn't seem to say anything about it being a perfectly straight line whatsoever.
Yeah, no, Bev's right. It uses perfectly straight lines, right?
They are from one to another. It's a perfectly straight line, but skip one and try to. Yeah, exactly. So you're getting the yeah. It doesn't have to be a direct straight line from the first to the last.
No. The starting point you have to establish a straight line with known measured distance. The rest of the time, you can just measure angles. That's the way triangles work. But for the starting point, you need a measured straight line distance. Now, the question is, does that prove a flat Earth? Is that the measured flat Earth that Nathan Oakley's talking about?
No. That's not. That would be a topographical Earth. That would give, if that was spread out to be flat, it would make the, I guess, circumference insanely larger than what it technically is. Because you're taking all those angles and you're flattening them out. You're lengthening. You're taking a three-dimensional line that zigzags
You
and you're
said you've measured it
straightening it.
anyway, so you don't need to worry about this.
I didn't say I measured it. I said
Measured the
I can get the
radius.
measurements. I got the distance
Measured,
of
you
the
said
radius
measured
from the
radius.
90th parallel to the zero.
Measured radius was your claim earlier. So you've got to be really careful when you use the word measured, because that can be verified. Can't it? It's things that have actually been done can be verified. And measured is a physics sort of thing, isn't it? It's a property of the physics.
How do you measure your straight line?
Precisely. It's the most precise measurement that you have to make.
Yeah. How do you do that?
Because it's the foundation.
The string?
Look into it.
The string stretched out?
I wasn't there when they did it, but they did do it, and it is documented historically for every land there is.
It says that they use sonar. It says that they use.
1785 they did it in America.
So they were measuring the distance of a straight piece of land.
No, from a point to an other point, straight.
Yeah.
line.
So for
usually
example, a new
not
way
on
of
the land, like above. Usually.
Here it says a new way of measuring distances in the waters is sonar. So if there is a ship at these coordinates and there's another ship at these coordinates and it sends out sonar to scan the floor or scan ahead, it can get the exact distance based on So that's a new way of doing it. I have no idea how the fuck that they used to do it or how they used to try and measure it.
Right? Their vertical distance measurements of the land.
Did they stick a bunch of inch rulers on top of each other into the sky?
I don't know. That's you're the inch man.
I prefer man of inches.
Oh, that's bad
Who's this Dalek? Exterminate! Exterminate!
Try leaving and coming back again. Connection's a bit iffy. Yeah, I've had lots of conversations with people about straight lines over the years. Some people in here the other day were denying it possible.
Yeah, it was Peter the Great. Man, in fact, told them, they're just baffled by what straight can mean, but they know what it can't mean.
Yeah, and I think
they haven't not that.
Yeah, they can't be here because they had to have interrupted me because we were talking about the straight line baseline. That's what I was trying to ask Nathan Oakley the other day. He could literally disprove Bob the Science Guy's modus ponens about Earth shape. You could disprove.
Who really cares about Bob?
Spherical. Do you care about disproving a spherical Earth?
Why is he a challenge? Why is he a challenge?
I'm asking. Do you care about disproving a spherical Earth?
I care about them proving it. Really?
Okay. Well, they can't, can they?
If I'm going to care at all,
you can disprove
I'm
it.
care
Then
at all.
are you still waiting for them to prove it?
I didn't need to worry about disproving it.
Okay.
But if I'm going to give a shit at all, and they're going to come in here and talk about it and claim that, reality is this way and that I don't observe and experience, and they've got the burden of proof. They've got to prove it.
Okay. Are you upset? Would you be upset if they came in to disprove flat Earth?
They can try all they like. I don't really care.
Okay. So it's about the positive proof, is it? Or is it about disproving the other one, or waiting for somebody else to give you a positive proof of something that you don't need to falsify? It gets a bit convoluted. So if you can you prove flat Earth?
You can demonstrate that the surface of a liquid at rest is horizontal and flat and level.
Have you convinced yourself through belief?
That's a measurement. Liquid at rest, the body of a liquid at rest, the surface is horizontal.
Yeah, I can make
flat and level.
Yes, you can measure.
That's that's the principle of liquid at rest, which you fucking rely on for your fucking water level. So don't give me shit, Bev.
Yeah, we've got to realise in Euclid test, it proves that a straight line lies within a plane. And sort of coincidentally, through the etymology of it and the enthymeme, we can say that level is horizontal. But I mean, we already knew that. We were just trying to relate geometric principles to reality. But can you prove a flat Earth? Or would that sort of do? Like proving the straight line lying within the plane. Is that the proof of the flat Earth?
Yeah, your topography, right, is going to be in reference to a horizontal plane of reference, right?
Okay. So proving the straight line lying within the plane is the proof of the flat Earth, and then measuring elevation changes from that then also becomes a proof of the flat Earth, right? Literally, the elevation changes that make it not flat prove the flatness, which sounds ridiculous, but is that what you're going with? Because if it is, can you prove a straight line? Can you? Anyone? Wow.
Yeah, sure.
Hey, what'd you ask? I wasn't paying attention. Say that again.
It appears that the proof that you need for the flat Earth is just this straight line.
What, like a laser line?
I don't know. That's what I was
Like
asking.
like a really high power, like a high powerful laser that can shoot straight.
Well, see,
if there is no deviation from the ground, then it would prove that the Earth is what? Not curving, right? And if the Earth is not curving, then what does it mean?
Well, when you do that, like if you're off the ground, are you classing that as Earth?
There's deviation. So if the Earth is running parallel with this laser for a very long distances, there's no deviation. Why are you interrupting me when I'm explaining this again to you?
Though.
Buddy, I'm explaining this again to you. If the laser is leveled off with the floor and it's going parallel with the floor over a vast distance and there is no deviation, what does that mean?
That you've
What's the argument for that?
I'm asking Bev. Who the fuck is talking?
I'm asking you for the argument.
Hey, listen, take your fucking argument, your sophistry, and shove it up your ass.
Bev. How about I fuck your daughter?
Just looking for a straight line.
Buddy, go back
Proof
to
of
school.
the
You don't know
straight line.
shit. Right.
That's all he asked, a straight line.
Bev, again, I asked you. If the laser is running parallel with the ground over a vast distance and there is no deviation, what does that mean?
It means you're using geometric terms. and parallel is well defined.
What do you mean?
Mathematics.
What do you mean? I'm
the
using
meaning of it doesn't need
in
to be
reality. If I
by
put a laser,
said the words.
He's not answering. He's not answering. He's fucking verbal diarrhea now. There's no answer there.
The laser is straight, and what's the other bit?
If it's parallel to the ground over a vast distance with no deviation. What
Where's
does that mean?
then?
It
Everywhere.
means
Well,
it's
you've probably been in with your builder's equipment, and you've made it level.
It's like as
Parallel.
you say.
Let's just say over water. Okay, let's say over water because water is level. Let's just say over water because okay, fine. No ground because ground has topography. We understand there's hills, valleys, mountains, all kinds of shit,
I
right?
think that's called moving the goalposts.
No, I'm not moving the goalposts because let's just make it so that it's actually level where water is level, right? So on the ball, right? On your ball, on this fucking spinning ball, the water is curving.
What
is it not? Well, the ball that they say, because this, what kind of channel are you in here, Bev?
Who's the first one? Go on. Let's admit it.
Who lives on a ball? Hey, Bev, do you live on a
that?
spinning ball in a vacuum of space? Bev, answer the question. Are you living in a ball?
Crazy person talking about a ball
Are you living? Are you? Well, I don't know. You guys, the Globers. Are you a Glober?
The hell's
Bev.
a Glober?
You don't know what a Glober is?
I've never fucking heard that word before.
Glober, people that believe they live on a fucking ball.
We were talking about straight lines. Can you remember us talking about straight lines?
You couldn't find a parallel on land, so you switched to the water.
Listen, there are parallel. You can't make parallel, but here's the thing. I fucked up on that one. I now admit it. No, I fucked up because I assumed Bev because I assumed Bev would understand what I was saying because he's been in this conversation for a very long time. But then again, he's a sophist and shit. But it's okay. Let's do it over water.
I don't know where this is
right?
going.
Because on this spherical ball, so these Globers think. Okay, so here's the background of the story,
don't tell
right?
me what other
so
people
these
think,
Globers, those Globers, listen, this is your whole fucking NASA and shit, right? So when they show you photos of Earth from space, or photos, quote unquote, right? These images of Earth from space, right? Do you not see the water that is curving on this ball? Yes or no?
Can you remember we were talking about a straight line?
Buddy, why are you not answering the question,
I don't
man?
know where you've taken it.
I'm taking it right to where it has to be, buddy.
About positive proofs.
Listen, exactly. So they're telling us that it's a ball, and what we're telling them it's not because there is no deviation.
Yes.
From the laser.
There's a famous
there is no deviation.
Bob the Science Guy, and he's done some
garbage
flat Earth logic of an argument that he uses.
Flat
and in
Earth
this argument,
logic.
he offers up his Earth sphere, right? In which I'm telling you, you can disprove the famous globe earther Bob the Science Guy and his Earth sphere. Yeah, you can disprove it. And you can disprove it by measuring a straight line. He even says it himself.
Measuring a straight line?
Yes.
What about measuring the curve? Prove the positive first. The positive claim is the ball. Prove it. Where's the fucking curve? Where's the 8 inches per mile squared? Why are you trying to fucking reverse burden of proof on us? We're the ones here telling you that, it ain't no fucking ball because when we measure it, it's fucking flat.
False dichotomy, and you can measure it.
No, what false dichotomy? No, man, you guys came in here saying it's a fucking ball with water sticking to this fucking ball, yeah? At a certain rate, it has a curvature rate. There's a radius to this ball. There's a curvature rate to this ball, but we do not find this curvature rate ever, anywhere we go. What's wrong with that? Your silence is amazing. I love it. Thank you. I'll go on mute. Don't worry.
I'd say that we can measure straight lines, and we do for the baseline to start off with.
Yeah. Okay. You measure over. Let's say you measure over 100 kilometers. Let's see you do it, Bev. Please, straight. Let's see you do it.
Is that a straight line?
Let's see you do that. Well, I want to see you do it.
Yeah,
I
but
want to see you do
when
it.
you
You're
think
talking
of it,
shit right
is
now.
that 100 kilometers? Is
I
that a
want to
straight
see you
line?
do it. Well, they have
At least
military
in your
technology,
mind.
right? They have military technology that can target shit for over like 100 miles. I'm pretty sure.
Is that
With
100
infrared and all
miles? Is that
kinds
a
of
straight
shit.
line?
But it's over a flat plane. Like let's say Navy ships, right? When they see
A flat
another
plane,
Navy
is that a
ship, yeah, these
pleonasm?
things are. And that water isn't curving though. There's no
using
curve to this
flat as
water. It's
being
not curving at
horizontal.
8 inches per mile squared, right? So the burden of proof is on these ballers. They haven't fucking proven the ball yet. You've been trying to do this for years now, Bev. You've probably been doing this for like close to like 6 years from what I can remember. You
Talking
were on
about
fucking
straight
not only
lines,
Gem
yeah?
Pandas, you were probably fucking on what's his name show, Nathan Oakley show, right? That's what you were on, right? That's where you come from. You've been doing this for so fucking long, and yet you still got fucking nowhere. Thank you very much. Keep doing it because you're fucking beating your head against the fucking concrete now.
Well.
Remember that you've been doing this for a very fucking
I've
long
come a long
time,
way.
right? And it shows fucking
My proofs are
everything
many.
about you right now. You've been doing this for many, many years, my guy.
Bev.
And I have many proofs.
Many years. You ain't got shit.
Awesome, Bev. Yeah, and we appreciate that. Seriously, why do you come here looking for a fucking fight?
I'm not coming. I'm pointing out that the straight line can disprove a model.
I know.
Well, in fact, it disproves
There's no model.
Like you're a salesman.
Mm-hmm.
You preach. You preach.
For the false dichotomy.
It's like you're upset. It's like it's triggered you that other people aren't thinking like you. You're not being specific enough. You're not using the same terms. You're misusing the terms. Blah, 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 blah. Like, okay.
It's all jargon. It's all his jargon. It's all his own creative jargon. He loves it.
Have you ever heard of the
Why does
phrase
it bother you so
coming to
much?
terms?
Why does it bother you so much? You got to come here and make sure that we hear your ramble.
Well, actually, I was coming here to try and let you know, in case you don't, that Nathan Oakley needs help to come here.
I don't give a shit what you think Nathan Oakley needs.
Well, I don't know. Are you the guy that runs this place?
I don't run
No,
this
Nathan
place.
has nothing to do with it. He never even really comes up unless it's you talking about him. I'm kind of sick of hearing about it, to be honest.
Same. Okay. Barely gets mentioned.
But wouldn't he be like a big name for you guys to...
No, we don't care.
He's a nobody. I actually hate that guy, to be honest with you. I've listened to him once. I'm like, yo, this guy's a fucking piece of shit. And that's it. I'd never fucking went on his YouTube channel ever again. What's up?
Yeah, I've only ever heard Bev mention Nathan Oakley in this channel. It's like the only time I've heard his name pop up.
This guy's like a fanboy or something.
Nice support there. Good to see.
Support? Why the fuck would I support that guy?
Confidence.
I don't need that
That's
bad
what we
asshole
need
to
going
fucking...
forward.
Yeah, that's what you need.
He told us the other day, 10 years. I mean, how long have you guys been in it?
Longer.
Longer?
Oh, yeah.
Have you convinced yourself with belief?
I don't need to convince. I know.
Is it like a...
There's no belief.
On a scale, right?
It's knowledge, my guy. It's knowledge, my guy. Trust me, it's knowledge.
Conviction.
More than what you know, I guarantee you.
Convinced himself.
It's not a belief. It's not a belief. It's not a belief. I told you it's not a belief. Why you keep putting words in my mouth?
Okay. But if you do have a proof, then
it's knowledge. I told you. There's no deviation from the laser. If you can show me deviation from the laser, then show it, please.
What, like a measured distance change?
Yeah, sure.
Of the land.
No, over water. Over water.
Like
topography will make the land. Listen, topography will make the land go fucking all kinds of ways. There's mountain, hills, and valleys, all kinds of shit. So it's never going to be flat. The fuck are you on?
Well, you know, they have a mean sea level, right? But that's because the sea level goes up and down. Like, is that what you're saying? To show you a deviation of the level going up and down.
I need a curvature rate, because the curvature rate is 8 inches per mile squared with the rate if the radius is fucking 4,000 miles, buddy. It's in the math. If you don't have that in reality, ain't no fucking ball.
Your man
Thank
measured
you.
the radius earlier.
Who measured it?
I don't know. Somebody earlier was validating a measured radius
Well,
of
I
a
don't.
circle.
Well, I don't know. It wasn't me, because there ain't no fucking radius.
No, you asked for it. I'm saying there was somebody here
You
earlier.
know the positive, the burden of
measured
proof
the,
again. Listen,
radius.
see, you're trying to reverse the burden of proof again. The burden of proof is on you, motherfuckers. Number
Why?
one, because you're telling me it's a fucking ball with this
I
radius.
didn't tell you that.
Yeah, you are, because you're a glober. So you fall. Hey, listen. You fall in their fucking team. You're falling under their fucking team. You know that, right? You
False
saying, "Oh, it's
dichotomy.
not me saying that."
I know.
No, you fall under their team because you're the one that's fucking coming in here preaching about the globe. Nobody else.
False
Well, I
dichotomy.
mean, all the other globers, you're fucking with them, man. The fuck out of here. False dichotomy.
What's the third option then? What's the dichotomy and what's the third
If
option?
you can prove both false, right? It's not a true dichotomy, is it? That's the way
That's
to.
not what a dichotomy is. A dichotomy means one is true or the other is true. So there's two positions that are juxtaposed to each other. So if there's a third position,
if it's
lay
a
out the
false
two
dichotomy,
positions
then you can
and the
prove both
third.
of them false.
No.
Why
that's
are
not
you
what
interrupting
that
my friend Hank?
That's not what false dichotomy means, bro. What's the two positions and the third?
Yeah. What you do is you set up this within logic and statements. You have a true or false statement, right? That's either true or false. Now that is a true dichotomy, either true or false.
Yeah. What's the two positions and the third position?
You don't need the third position. That's right. Some ways
you do if it's not a true dichotomy, brother. If it's a dichotomy, there's only two positions.
Yeah, and if both
if
of
there's
them
a third
can
option
be proved false,
that you're claiming, bro, that's irrelevant. If there's a third option, we just want to know what you're talking about.
Okay, so if you can prove both of these options false, that's how come you can say it's a false dichotomy. Because you can prove them both false. That means there is at least one other option.
What is it? What's the other option?
Not either of the false dichotomy, but most of these arguments are based
you listen to this guy? What a snake!
The false dichotomy, aren't they?
A slippery snake, you know that?
I only come with sort of proof of the straight line. That's all.
So you get a straight line. What the fuck does that prove?
You can start from a certain knowledge. Something that
and
you
what would that
actually know.
What would that be?
Well, you could base the rest of your understanding upon something that you actually know. I know, it sounds simple, doesn't it? It sounds too simple, really.
Quite simple, really.
Yeah, it's more foundational than anything, really.
So you're telling me you're lost in the sauce, okay?
He's telling you it's so simple, but he's not going to take you from A, B, C. It's just going to be coy, and I'm not going to get any new information. It's just going to be a bunch of dickheads swinging dicks at each other. Freaking boring.
You've got to get yourself.
Yeah, I'm sorry. I couldn't resist.
Oh, something you got to get yourself.
Yeah, the understanding.
Yeah, the Glovers use that on me all the time.
Whatever, dude. Why don't you enlighten us? Since these guys are clearly struggling and you've paved the way ahead of them, why don't you give them some information that's useful instead of just dicking back and forth?
What about how to measure mean sea level, vertical datum?
Oh, dude, why don't you present to them an argument that lays out your premises and carries your conclusion of a necessity that's easy to follow? I mean, I don't know, do something.
Well, we've already done it. We've made the arguments already. I don't think anybody can rebut them. It's just that they trouble the false dichotomy. So
I don't know, dude. You haven't really made an argument since I've been listening.
There you go.
Unless you mean you made it last week or something.
made
Well, he
it
didn't make shit.
a while ago. Do you want me to give you an argument? Let me get it. I'll post it in here.
I like listening to people make their points. Like, these are my premises. These are what they mean. This is the conclusion. It carries necessarily. Therefore, this is that. That's the way I like it.
I went into a study of the argument, and I think I can make this the most simple argument that can connect logic, mathematics, and reality together to let everybody see the simplicity of it all, right? And now it goes like this. Call it the argument. If P, then Q. If all horizontals are parallel to the plane of the horizon, P, antecedent, then all horizontals must be parallel to each other, Q. Modus ponens. Somebody. By affirming the antecedent, modus ponens. Okay? By definition, all horizontals are parallel to the plane of the horizon. P is true. Modus ponens. Therefore, if P is true, then Q is true. All horizontals will be parallel to each other. Q is true. Corollary to that argument, the plane of the horizon will always be horizontal. The law of non-contradiction states that no statement can both be true and false concurrently. Therefore, a modus tollens for the argument will be impossible. The argument.
And that's why I don't click up.
I mean, that's a necessary property of horizontal. A horizontal can't exist in a globe paradigm. It's incoherent in their worldview.
It's just an argument called the argument. You can argue against it. I say that the modus tollens is impossible, but anyone can offer one up.
Right, so if anything is laying on a horizontal plane that's parallel to all other horizontal planes because it's parallel to the horizon, then what orientation would it have in free space?
Horizontal. In reality, you can't get rid of horizontal.
Right, so what orientation is horizontal?
Horizontal, parallel with the plane of the horizon.
Okay, and what's the horizon?
The plane of the horizon would be the totality of the plane of the what you call the horizon. That encompasses also the topographical horizon, because you're rotating 360 degrees. That plane that the horizon is within is classed as a horizontal plane.
Fair, but a topographical horizon would have differential points on the plane, so you'd actually have multiple points that are different in the y-axis relative to the initial plane. So it wouldn't actually be horizontal if you used topography.
Are you saying that the plane of the horizon isn't horizontal? Because, I mean, it is.
Oh, I'm saying that is if you have multiple points. Right, but if you say the horizon is topographical, now you have multiple points that aren't on the same plane
of the horizon.
Right, but then you have an error because you're saying the topographical horizon. So then you're not. Then the topographic horizon isn't a true horizon. Then.
Yeah, the plane of the horizon. So that's why we talk about the plane of
Yeah,
the horizon.
What's the horizon?
Horus sunrise.
The totality, the tal, of the horizon, horizontal. The horizon, as you turn around, the plane of it where it meets itself, it's called horizontal. All horizontals will be parallel to that plane of that horizon,
right.
No matter where you are.
Right, but if you're standing in a valley, let's say you're standing in a valley, right, and you trace the quote unquote topographical horizon, you're going to have like an EKG meter, up and down, up and down, up and down. So that isn't on the same plane. So to call it a topographical horizon would be incoherent.
The plane of the horizon. Do you hear? Horizontals are parallel to the plane
a topographical horizon,
of the horizon.
I know you could keep repeating that, but I'm parsing it out how it's doesn't fit in this instance.
It doesn't fit in the argument that states if all horizontals are parallel to the plane of the horizon P, then all horizontals must be parallel to each other Q.
Okay, but then if you have a topographical horizon, then you're defeated.
What, the argument's defeated?
If such a thing as a topographical horizon exists, then yes. Because it has points that aren't parallel on a plane. Because it's not planar.
Points aren't parallel. Never are. Never have been. Unless you've got a definition of point parallel. I've heard it talked about.
And if you have a topographical horizon, you have multiple points, right? That are on different levels. They're not on a plane with each other.
Yeah, differential leveling.
Correct. So you can't call a horizon a topographical horizon. That makes no sense. It's incoherent. It's incoherent and self-defeating.
It doesn't mention topographical horizon in the argument.
Okay, so then topographical horizons don't exist then. Good.
But not within the argument. The argument states if all horizontals are parallel to the plane of the horizon, P, then all horizontals must be parallel to each other.
Well, yes, but so the plane of the horizon, we know what a plane is. What's a horizon?
The horizon. You could Google it if you want.
Dude, I'm asking you. You're the one making this argument. You need to parse your terms.
Okay. The horizon is that which the plane of is always parallel to the horizontals at the location.
That's a tautology. That's not a definition.
It's an argument.
No, it isn't, dude. It's a tautology.
You seem to be trying to rebut it. You're attempting a modus tollens.
No, I'm asking you what a horizon is, and you're offering me a tautology.
No, you offered. Like you said, have you got any arguments? And I showed you an argument, and now you're asking me.
Yeah,
for
I like it. Now I'm parsing
definition.
it out, but I'm having a hard time. I'm having a hard time getting to what a horizon is. That's what's bothering me.
Well, your understanding of horizon is, I don't know.
No, I want you to parse it from your argument so that I can understand your argument better.
Mm-hmm. Do you know what a horizontal is?
Okay, I asked you what a horizon is.
Yeah, and I'm trying to relate
That's the question that's on the table.
I'm trying to relate it.
You haven't answered it. You offered me circular reason tautology.
This is really weird.
Yeah, I know it is, isn't it? What's a horizon, please?
To me, horizontal. The horizon is horizontal. Yeah. How about that?
Well, of course, that's a property that horizons have, but what's a horizon?
So you're saying that the topographical horizon has a property of horizontal?
No.
Okay.
Topographical horizons don't exist because they're not horizontal.
Okay, so are you saying
The reasons
that the
I already
horizon
parsed
has
out
to be
eloquently.
horizontal?
The horizon has to be horizontal. Let me tell you why. It's very simple.
The plane
Because
of
the
the,
term
this is why I say
horizontal
the
is
plane of the
derived from
horizon.
the term horizon. The term horizontal means parallel with the plane of the horizon. So you need to know what a horizon is in the first instance. That's the thing that hasn't been parsed yet, which is the foundational point of this whole argument.
Okay, well, like in order to speak of it as its whole, would you not need the entire plane? Wouldn't you need to be talking about the plane of it rather than just a part of it? You want the whole of the horizon, so therefore you have to encompass the plane. You can't speak about a part.
Okay, so you're changing the definition of horizontal from an optical phenomenon to the nature of the Earth, right?
Horizontal isn't a optical thing, is it? Although I suppose you could see water and that be your best relation to horizontal, but
Well,
I don't know.
what's the
You'd have to
horizon?
look into
What's the
it.
horizon in the first instance from where we derived the term horizontal in the first place?
I don't know. I've got a clue. Whore. I don't know.
Really? That's your answer?
Well, I know
You don't know what the
what the
horizon is.
plane of the horizon is because I obviously understand it. I've made an argument about it.
Yeah, yes, but if you have the word of, right, and you don't know what the horizon is in the first place, then you don't have a definition of one of your terms in your argument, so your argument's pointless.
So you're going with the semantic approach.
Dude, if you're making this argument, you should know what the words in it mean. Don't you think?
Yeah.
Whether you go with a convention or whether you make up the definition yourself, that word should have a meaning.
The plane of the
Otherwise,
horizon,
I could just put whatever I want in there.
Yeah.
If you're going to leave one of your terms undefined and open, then I could just put whatever I want in there.
Okay, so do you think the plane of the horizon is an undefined term?
No, in your argument, horizon is an undefined term.
Wow. Why?
Because you haven't defined it. I've been asking you for like 3 minutes now.
Like, does that...
Okay, you can sit there. Look, you could sit there and keep playing coy, dude.
Yeah.
But it's obvious to anyone listening that's able to follow the train of thought here that you haven't defined what horizon is. So
Okay,
by
the
all means,
argument
go
doesn't
ahead.
need to define the horizon, does it?
Yes, it does, dude. That's your problem here.
Okay.
You
Well,
think it doesn't, but it does.
In this, the horizon is defined as being horizontal through a reasoning process. That if all horizontals are parallel to the plane of the horizon P, then all horizontals must be parallel to each other. Now, that's not just a statement that we're saying. There is a geometric backing that goes with that, right? So we just change the words of a geometric proof to this to make it relate to reality. This is why I say I call this the argument, because I think this is... I challenge anyone to make a simpler modus ponens to link reality,
Dude,
geometry, and logic
you haven't
together.
defined horizontal yet it's a term in your argument.
By definition, all horizontals are parallel to the plane of the horizon.
Okay, perfect.
You can
Stop
you
right there.
can
What's
look
the
that up
horizon?
yourself.
What's a horizon?
Ask AI bot or something like that. ChatGPT. Are
What?
all
Dude,
horizontals
why do I
parallel
have to
to the
look up
plane of the
anything for
horizon?
myself, dude?
Because that would
Dude,
be
I understand
validation of
planes.
the statement.
Dude, listen to me. Pay attention in your argument. I understand what a plane is. I understand what parallel is. What's a horizon? You haven't defined that in your argument, okay? Please define it.
It's defined as being that which all horizontals are parallel to within this argument.
That's a tautology.
Can you falsify
Insufficient.
it?
How can you falsify
Sometimes
a tautology?
tautologies
Good
are
grief,
really good
dude.
things, right? That's why I said there will never be a modus tollens for this.
Oh my goodness, dude.
This is
What's a
called the
horizon?
argument.
What's a horizon, Bev? What's a horizon, please?
You sound like Nathan
You have an
Oakley with his
undefined
radius
parameter in
thing.
your argument. What's a horizon, please?
Address the argument.
I can't. There's undefined terms. What's a horizon?
What do you imagine the
Okay,
horizon
I
to
already
be?
conceded to you that parallel
Do you
planes
imagine
will
the
indeed be
horizon to be
parallel to each
something
other.
other than parallel to horizontal?
What is
the
it?
plane of the horizon. Parallel.
Okay, so the horizon, you're telling me that the horizon is the plane of the horizon. That's your final answer?
We're talking about the plane of the horizon.
Okay, excellent.
Okay.
So the plane of the horizon of the requires that the thing needs something of parameter defined before it could be of anything. So of the what?
Okay.
Of the chocolate cake?
Right.
Of the Easter
we've
bunny?
said it's a plane, right? It's a plane is a geometric term. People understand what that is, don't they?
Okay, so then your claim is the horizon is a plane. That's your claim.
The plane of the only thing that you can say about the plane of the horizon, or other than, oh look over there's the horizon with point with finger, right? The only other thing you can say is that the plane of it is horizontal. You can say that for sure. Certainty.
Okay, so you just screwed yourself because now you have two things. You said over there is the horizon, and then you could say something about it, which is the plane of the horizon. Those are two things. So you've now destroyed your tautology, and now you still have an undefined parameter. So what is a horizon, please? For goodness sakes, how hard is this?
Go round and round and round and round.
Yeah, you're going round and round because your argument is malformed because you have an undefined parameter, dude.
Okay, so
the very foundation of your parameter is missing.
There's something wrong within the definitions that we should put
Dude,
before the argument.
No, you haven't defined the horizon yet in your argument.
It's defined as being horizontal within this argument. It's a corollary.
Okay, so what you're saying is the horizon is defined as horizontal. So basically, the word horizon and horizontal are the same term in your argument.
It's the enthymeme of this argument that the horizon is horizontal.
Yeah. So then restate your claim, or sorry, your argument without using the word horizon. Just use the word horizontal, because if they mean the same thing, identical, then A equals A. You could just put A. All A's are parallel to A, therefore A is parallel to A. Well, duh.
Yeah, perfect arguments become tautologies of their own. In the way that they cannot be proved false. Which is why I call it the argument.
Okay, now that's great. So now we have a bunch of planes that are parallel to each other. Great. Now what?
Now we can relate measurements to those. Call them elevation.
Well, what orientation are the planes?
Horizontal.
What's horizontal?
Oh, God. Are you okay?
Oh, I'm more than okay.
Brilliant.
I mean, is horizontal an abstract entity that exists in free space with a reference frame dependent observation to understand its orientation, or is it linked to a substructure? I mean, what is it, dude? Like what?
It's a usable, practical thing that we can use in reality, isn't it?
Yeah, why?
Why?
Yeah, why? Why is it useful?
Because you can reference things to it.
Oh, that's actually a very good use. So what type of reference would I use it for?
You'd use a horizontal and vertical reference frames, wouldn't you? 3D reality.
Excellent.
Well done. Well done, that man.
So if all planes are horizontal, right, that are horizontal, then if you have a horizontal
planes
plane,
are parallel.
right, they're parallel to each other, but they're all also horizontal necessarily, correct?
Dude, listen, all horizontal planes are parallel.
Correct.
Right, that makes
That's
all
the
of them
definition.
both horizontal and parallel to each other. It's quite an easy, simple statement. I don't know whether you're actually hearing the words that are coming out my mouth.
Oh, well, dude, if you define horizontal planes as parallel, right, then of course they're parallel. That's their definition.
Yes, they are defined. It's not me. I'm not defining them. I'm saying horizontal planes are defined as being parallel to the
Okay, so
plane of the horizon.
why is it useful? Give me a practical example in reality I could use this for.
Have you ever heard of differential leveling?
Oh yeah, I do it.
Right, well, there you go. You're using parallel horizontal planes to measure the elevation change of the land, aren't you?
Absolutely. Now, if I level a piece of land, what orientation is it? I'm not being facetious. If I level a piece of land, what orientation is it?
Doing differential leveling? When you mean level it, do you mean just take the measurements of the elevation points, or do you mean like you get in a bulldozer and?
Well, I want to understand
I
what
want to
I've
know
got.
whether you're a
I can get it.
surveyor or a bulldozer driver. I don't know.
Well, look, I want to build a building, right? And I want to make a level foundation, so
Are
I
you
need
an
a level piece of
architect?
land. I want to level the land, right? So once I'm done leveling the land, okay, once I'm done leveling the land.
Are you a surveyor, a landowner,
okay, once
a
I'm done leveling
builder,
the
an
land,
architect?
once I'm done leveling the land, and okay, we'll get there, don't worry. Once I'm done leveling the land, what orientation is it? Anybody? Bueller? Bueller?
What are you asking? Once you level the
Once I'm
land,
done leveling the plot of land that I'm going to build on, what orientation is it?
well, it's not vertical, is it?
Dude,
Levels horizontal, dude. Like, I
There
thought
you
you
go.
said you were a
okay,
surveyor. Are
perfect,
you a
perfect.
surveyor, a builder?
Right. So I leveled a piece of land, I flattened it out, and it's horizontal, correct? Yes or no? Yes or no?
Did you roll it? Did you get a roller on it?
For the love of God, I leveled it and I flattened it out.
Yeah.
What orientation is it?
And then afterwards, did you check to make sure you were precise enough to be able to call it level?
Okay, I just told you I leveled it and flattened it. What orientation is it?
Well, it would be horizontal if you'd done it correctly, but I mean, let's presuming because level is horizontal.
There you go. So now, look, you could fairly argue ad infinitum into precision. That's a fair argument. However, in the real
It's
world,
not an
we
argument.
can't do
No,
anything
that would just
perfect.
be me sort of being precise, right? Because you've got
But look, that's
superiors
fine.
that come
That's
and check
fine.
that make sure that you're doing your
That's
work properly, right?
fine. That's fine. That's fine. But the point is that there's tolerances, correct? In practicality, right?
I don't know. Is that what tolerances to your superiors stick to? You know more than me.
Yeah, dude. Dude, in everything you build, there's tolerances because you can't do anything perfect. So if you have a level, flat, horizontal piece of ground, right?
Peace.
And that's the way that Earth is oriented, and you have an equilibrium of forces that you can literally take your level, and it'll sit horizontal and show that it's level, right?
Yeah. Do you think you could measure it flat?
Oh yeah,
What would those measurements look like?
0.
So do you think measuring nothing is actually a measurement?
Yeah, you measure no variation in the vertical plane.
But I could measure nothing like right here where I am right now, couldn't I?
Like, listen, if you have a level, flat, horizontal thing, and you measure it in the vertical plane, right? It's going to come up 0.
Well, that's what I'm saying. Is a measurement of 0 a measurement?
Well, yeah, it's a measurement of no variation in the
It's like a
vertical.
measurement of no measurement is actually a measurement. It sounds like a brain twist sort of thing, doesn't it?
What are you talking about, dude?
Well, it sounds like a nonsense.
Yeah, your nonsense, bro. Anybody who builds understands this quite simply. It's not that complicated.
So you a builder then?
Okay, let's be clear. A plane has no value perpendicular to the plane.
That's why we talk about the
All
plane of the
measurements are
horizon
points
being
on the
horizontal.
plane. Right.
Yeah. So any deviance from the plane would make it not a plane, wouldn't it?
Correct.
Yeah. So in reality, when we do measure a change, then that would be measuring a deviance from the plane. But that horizontal would be established above the ground, wouldn't it?
Oh, you can establish it anywhere. Just because the ground's in your way doesn't stop you.
Well, no, I'm
You
saying
just kick the ground out
when
of the
we
way.
do our surveying, right, that horizontal that we're referencing the measurements to, that's above the ground, isn't it?
Yeah, so there's the question. If you're above the ground, how do you get a horizontal to begin? Where does it come from? Anyone?
Good question.
It's the only question.
Can you repeat it, please? I've just popped in.
So we're trying to establish a level, horizontal, flat plane, right? For a baseline of my building, right? And since the ground is an imperfect place to start, obviously, you need a reference, right? To get a level from which to level the ground. So where's that coming from? Because you're pulling it off the ground. That way there's no impedance of the ground. So where's the level coming from?
You establish it within the auto level or whatever, above the ground.
Yeah, but what is establishing it?
The tool.
Plumb bob?
Tool's called a level.
You could.
Yeah, we have tools called levels.
Yeah, you got levels, you got plumb bobs, but they all do a particular thing. What is it that they do?
Find the horizon.
The what?
Serious. This is a
They
schooling
find
session.
a
plumb
No,
bob
hold
will
on. Let him
establish a
say what he's going to say.
vertical and a level. A tool called a level will establish a horizontal plane of reference. Now, both of them is above the ground, unless you want to go under the ground
how do
through
they
like
operate,
mines
then?
and
How do
stuff
they
like
operate? How do they operate?
Usually they require an operator, somebody to measure either vertical or horizontal distances in practical reality.
No. How do they operate in themselves? In order for you to trust that a level's doing anything for you, or that a plumb bob's doing anything for you, you have to understand the principles on which they function. Otherwise, they're useless.
Or meta.
Yeah, what is it
You
about
need to
a plumb
understand the
bob and a
meta
level?
to a plumb bob.
Absolutely. What is it about a plumb bob and a level that makes them useful?
Reference frames, vertical and horizontal.
Yes, they orient themselves to the reference of the realm in which we live, which all things are referenced to.
You know, I said that, like I said it earlier, the horizontal distance will be the shortest distance between 2 points.
Huh?
You know, if you get 2 points in reality, equal,
Yeah.
obviously,
I
not at an equal elevation on the horizontal, then there will be a longer line because that line will become the hypotenuse.
Because if you're looking at them at 3 stacks, they'd be going diagonal.
Can
If you
be
put them
measured
into
through rise over run, right? So therefore, horizontal is a necessary shortest distance between 2 points.
Right. So how does
reality?
Absolutely. So how does a
That's why the
level that you use to
baseline
build
that we
one?
started off at has to be on a horizontal and measured accurately.
Absolutely.
That distance.
So when you have a
straight line distance.
When you have a level, what are the parts of a level?
Point A and point B.
What?
Yeah.
The parts of a level are point A and point B?
Yeah.
What the
equal elevation.
How do you know they're equal elevation?
Because they're level. That's what.
And how do you know that?
How do you know level?
Well, and look, in your hypothetical, you define them as such. So let's go to the real world where you actually have to tool these things and not just guess, right? So what tool are you going to use? We already established a level. That's what I'm talking about, a tool. How does that tool work? What are the parts and what do they do?
Okay, there's a
what do they
tube
do?
and some water, preferably distilled water.
What? You think they got water in there, bro?
For my favorite tool.
Oh, wait a minute. Are you hold on? Are you talking about a water level or at like a builder's level?
No, a water level.
Okay, perfect. All right, go ahead then. My mistake.
Point A and point B, the points that you want to establish as being in equal elevation. You would use a water level. You would put one of the water levels at point A, one of the ends at the place that you want, and move another one to the other position that you want to establish an equal elevation. Pretty simple.
Okay, perfect. So is the water itself level?
Those 2 points would be like the water
Right.
would be
So
the water.
just the surface points, just the surface that's at the tip of the tip top of the tube, or
but all of the points are an equal horizontal.
No. The only part you can use as a metric.
State.
Yeah, fair. But the only point you can use as a metric is the surface of the water, right? Unless you create some other type of
for the water level, all you really need is those 2 points at the surface.
Well, those are the only points you can use, correct?
Well, I mean,
generally,
you could use somewhere else, couldn't you? And tap in a pressure thing.
How?
By putting a diversion T-tap or whatever and establishing a pressure monitor or somewhere else along the line. I mean, you could do whatever you want. This is in reality, right? It's practical sort of shit.
Okay, so at level, that water has reached a different equilibrium. At the surface, it's obviously reached a horizontal plane of equilibrium, right?
Equal elevation.
And then
yeah.
each pressure state below the surface, right? Each pressure state below the surface, you could say, is on the same plane as well. That would, I mean, that would be pretty fair to say, I think.
Yeah. Straight lines. That's what it's all
Right.
about.
So the builder's level,
2024.
the builder's level works the same way, right?
Yeah. The question is measuring that straight line, measuring the Earth flat? And I'd say with a false dichotomy, yeah, you can. You can make that measuring the Earth flat. You'd have to completely forget about the vertical. Oh, in fact, with Bob's, if you use it as a rebuttal to Bob's modus ponens, because Bob says any 2 points in any direction, you could say that vertically. You could literally measure a vertical straight line distance as a modus tollens to Bob, the science guy's modus ponens.
I'm not familiar with what his is.
You know, Bob, the science guy's done some brilliant. He had a video out called Flat Earth Logic.
No, you screwed up.
Now.
You screwed up. You just said Bob the science guy done something brilliant. That's where you done screwed up.
But you not even want to see it. You've got to see the brilliance in this. I'll get it. I'll put it in the chat for you. Bob the science guy. We're trying to get him. You know.
Yeah, so it's like this, bro. If you claim that horizontal is parallel to the plane of the horizon, right?
Yeah,
and all those are parallel, and then you create 2 points and call them horizontal, right? And you use the equilibrium of water as that claim, right? Then you basically have said that the entire surface of the earth that's covered with water, right, is on a similar plane.
Goes up and
right?
down.
So therefore,
all the horizontals,
it's a plane.
But the water goes up and down. It's measured on the vertical data.
That don't matter, dude.
Have a look in the chat there, Bob.
Well, dude, if you're going to parse out the variations in the vertical, right?
Yeah, measured vertical change.
Oh, of course. Then you'd never be able to establish a horizontal.
You can establish a horizontal.
But how?
What? How do you establish
No,
a
I'm dead
horizontal?
serious. You gave
that.
me the water level. You gave me the water level, but we all know that the surface of water, has all kinds of undulations in it. Right?
Yeah, water level is the tool that you use for establishing equal elevations, a horizontal plane. There's no slope to a horizontal.
Are they?
There's no slope to a
two
water
ends
level.
of the water? Yeah, perfect. Is the two ends of the water level microscopically at the same elevation relative to each other on a plane reference?
Yeah. Yeah, it's the
You're
most
certain
accurate.
of that? How'd you
It's the
validate
most
that?
accurate
How'd you validate
means
that?
of elevation check that we have.
Okay, so it's just the most reduced accuracy, correct? It's not perfect, correct?
I've heard that you can get a 50 millionth of an inch accuracy with little needle things touching the surface.
That's not an infinity accuracy, so it's wrong.
Okay. Seems to be. I don't know. What's the argument again?
Well, the argument is precision, right? Precision. Perfection.
And you don't think a 50 millionth of an inch is
no, dude, a
enough?
50 millionth of an inch on one side and a minus 50 millionth of an inch on the other side makes that a diagonal, not a horizontal. Correct?
Well,
yes, that would be
that's just the
correct.
measurement, right? doesn't mean that the actual water level
Right. So
isn't
now that I've proven
perfect.
that you have no mechanism
Just means
whatsoever
that
to
you can't
establish an
measure it.
ideal horizontal, your entire point is moot. Thank you for playing.
Can't have a horizontal, Beth.
Well, I have to point out, that doesn't mean that the surface of the water is perfectly horizontal. It just means we can't measure it, but we can measure it up to a 50 millionth of an inch. If they have better technology, they might be able to get closer.
Well, maybe, but then until then, it's a pipe being an ideal.
The water.
Okay. Until then, it's an ideal concept.
The water is an actuality that we can't get to measure. We can't get that accurate.
I mean, dude, that's your claim so far. So far, your claim relies on future proof. So now in the future, when they have this magic technology, then we'll know for sure. But until then, we don't, right?
Well, no, I say I have proof, but it depends on what you.
Dude, your proof exists in an ideal conceptual state.
Proof, yeah.
You haven't validated intangible reality yet.
Proof.
All of you've proved to me is that within a certain variance, you can claim a general horizontal, not an exact horizontal. Because from what I gather, you have the probability of it being diagonals. So you can't actually tell me whether the realm is arranged horizontally or diagonally.
Diagonally reference to what?
Yeah, exactly. So thanks for playing.
Yeah, thanks for your rebuttal.
Yeah, you're welcome. That's what happens when you go down the pedantist precision little avenue. You find out that your idealistic claims aren't actually validated in tangible reality yet. Now, intuitively, I would agree with you, but precisely, I've done validated that you can't prove that it's not a diagonal.
Okay. Well,
so go ahead and keep making your claim.
What about if somebody was going round confidently stating that the Earth was measured flat? Would you have a similar sort of rebuttal about, in measuring that, since he is measuring the straight line?
Oh, well, I would demand that they parse all their terms so I could understand what they mean by that. So I wouldn't make the jump to the gun assumption that they're saying the Earth is smooth. Right? Because some people will use the term flat to mean smooth, and some people will use the term flat to mean orientation. For example, laid out flat, which is parallel to horizon, which is essentially a synonym for horizontal. So if somebody told me the Earth was flat, I wouldn't be a pedantic asshole to them and say, well, no, it isn't because it's not perfectly smooth. I would dare not do something that dumb.
Right. So would you say, like, if he was measuring something to within a 50 millionth, would that be all right if he was measuring it flat to a 50 millionth of an inch?
Well, look, we all live in reality, right? And that's where we operate. We don't live in ideals.
Yeah. Because
so intuitively, I generally understand the Earth.
An accurate.
What's that?
Would you call a vertical change like an accurate, like the most accurate, like, what do you reckon? The most accurate, do you reckon that would be a horizontal distance or a vertical distance?
Well, hold on, go again.
If you were measuring accuracy within reality, do you think you'd be able to measure the distance between 2 points more accurately, or the change in elevation between those 2 points more accurately?
I mean, if you just want to do a linear distance, I think the linear distance would be easier. Primarily because most linear distances on surfaces are connected to the surface, right?
Well, I
so
mean,
you have the
obviously,
surface
right?
to use.
If you've got 2 points in reality, imagine in a scientific lab or mathematical lab, right? In school, just 2 points. You'd need to know 2 variables at least, wouldn't you? Now, the question is, which one of those two do you reckon you could measure the most accurately? Or would you just consider the distance between those two? And how would you know that? Like, that's
Oh
the
no, man.
question.
If
It's a
you, well,
mathematics
I mean,
question.
if you just want distance, if you purely want distance between 2 points, then whichever way they're oriented is the way they're oriented, and you just take the distance.
You just measure straight
But
out the distance.
if you're going to make it mean anything in relation to other objects in terms of orientation, you would have to put them into a matrix of horizontal and vertical. So you'd have to assume the existence of the horizontal in order to put them in any meaningful information state.
Yeah, and then the question comes, which one of those? Do you reckon that horizontal distance would be more accurate, or do you reckon the vertical distance would be more accurate?
Well, do you mean compressing all the y-axis first into like an assumed horizontal?
I don't know. You said earlier about like your standards of accuracy. So I'm saying, like, if in these measurements that we would be making, do you assume that the horizontal distance would be more accurate, or the vertical distance would be a more accurate measurement? Bear in mind, I have just given away the accuracies of a tool that measures elevation changes. How accurate do you reckon you could measure a horizontal distance?
Most horizontal measurements are longer than most vertical measurements that people take for all practical uses. So the smaller you get, the more variables you're going to have, right?
Yeah, but wouldn't you measure the vertical distance over the same parameters? You'd need both, really, wouldn't you? Like I say, this is what I say. You'd need both the horizontal and the vertical to measure the most accurate total distance.
Yeah, you need, well, if you're going to measure, well, yeah, of course.
Right, so I'm just saying, which one do you reckon is more accurate whenever you imagine actually measuring these?
It depends on your tools.
And which do you reckon is the most accurate tool for measurement? That's what I was saying. That's basically where we're getting at.
Well, the most accurate tool on a plane, right, that has physics would be the thing that let's see, most accurate tool for measuring a horizontal level horizontal base would be water.
Now the question is, how do you prove that water level is level, horizontal?
Well, this guy's being a pedantic asshole again, guys. I'm going to sleep.
Oh, well, that's literally the definition. Right? So you have to accept the base definition. So if you're a Glover, you have to accept that level in its ontological state on the earth is curved. And transversely, otherwise you just say it's not.
Benzizontal.
So in order to validate it, you'd have to use something else, right? You'd have to use a second tool.
Now, do you imagine what you're thinking has never been done?
Oh, that a second tool has never been used to validate a water level?
Well, what's the point? What you're doing? You're trying to validate that the water is level. What you're trying to validate?
Well, I mean, it's level tautologically and axiomatically and definitionally. So that's a good point. Why would you bother validating it?
Because all horizontals are parallel because they're all parallel to the plane of the horizon. Like you can make that link. But the proof would be like obviously like a geometric proof, wouldn't it? Like there's got to be a way to link this thing with a mathematical geometric proof where you can go through this process where you're reasoning these things. But I mean, it all starts with the straight line.
You already gave the mathematical proof.
Well, actually, you didn't see the mathematical proof, did you? It's like it's one of those.
Your mathematical proof is already given.
Statements, yeah. But do you know which
one? Look, a parallel plane, right? You could give a formula, right? You could give some math that a parallel plane is parallel to itself, or sorry, a plane is what it is defined mathematically, and another parallel plane to it is going to be parallel. I mean, there it is. Unless you mean another tool, right, that you're going to use and then use some math to show that it proves the other thing's level. But how would you orient that thing in free space? Think about it. You'd use the same tool, the water, to orient the thing that's going to gauge the water.
Yeah, mathematical proof about straight lines. Exactly. You'd link that to reality through the use of a tool that establishes a plane. You'd link the straight line to the plane geometrically. Oh, well, at least I would. I did.
Oh, so you've done it, right?
Yeah, I called it realizing Euclid.
Oh, great. So when Homeboy asked you like an hour ago for that, why didn't you just give it to him?
It's more of a journey, isn't it? A straight line lies within a plane. How do you prove the straight line? Basically, what I was asking you to try and, spark interest.
I don't think they took it as interest being sparked.
Yeah, I know.
Maybe it's your dry tonalities that made them feel like you were just being pedantic and coy. See, not everybody wants to go on these little journeys, you see. Some people just want somebody else who's already done it to just wrap it up in a nutshell with a clear, concise presentation. And when they're asked, be like, hey, bro, I got this presentation. You can check it out over there. But since I'm here live, I'm going to do this with this conversational tactic. Right? That would be way more productive.
Yeah, but that doesn't really involve
because,
everybody. I like try and get more people involved in it, but there always seems to be people like, wanting the presentations and stuff. But then, when we actually did the presentations and stuff, nobody wanted that either. That's the strange thing about it.
That's the problem. That's why you got to do both.
Seems like nobody knows what they want.
Well, sometimes you feel like a nut, sometimes you don't.
I blame the fact that I don't think people have proof anymore of their own, so they don't really know what it is that they require. Imagine that they can get it from some sort of presentation or something. But that's
Well, why don't you
modern
put a
day life.
presentation out about how they need a presentation to get their proof?
Well, I do one about how to measure the Earth flat. How about that?
There you go.
Call it Helping Nathan Oakley, because he needs a bit of help.
Well, you see, we got a lot of camps, right? And all of them think that their way of thinking and their way of presenting and that the niche in which they're involved in is somehow superior and more advanced, right? Sometimes. And then some people come along and they're like, yo, I'd like to know what you know. Could you tell me, please? And then they got to go through this like trial by fire. And then they're like, whatever, I ain't got the time for that nonsense.
It's simple. It's about a straight line. We go advanced simplicity, right? I mean, most people already know it. Surely, the shortest distance between 2 points is a straight line. It's just most people can't see the implications of it, where that leads.
Well, even the Glober nonsense rhetoric. You remember this, on a globe, the shortest isn't a straight line, but they're wrong, because when they say straight line, they mean curved line. They mean straight in one axis, but curved in another axis. So it's not a true straight line. A true straight line, which is not curved in any way, shape, or form, would tear straight through the surface of the Earth to the other point if the Earth was a globe. So when they say the shortest distance isn't a straight line, they're actually being dumb. Or redefining what straight means.
I'm not redefining what straight is. Well, that's what I opened with earlier today. The question is measuring that shortest distance between those 2 points as a straight line. Is that measuring the Earth flat?
Depends on where the points are.
Yeah. I think that's what you should be asking. Like, because with Bob's Modus Polens, which I did put in the chat, did you watch it? He even offers
I've been
up a
talking to
Modus
you the whole
Tollens
time.
to it.
How could I have watched it?
Nathan Oakley didn't want to take it either, like you guys. I'm trying to sell it, really.
Do you think the surface of a sphere is 2-dimensional or 3-dimensional?
Doesn't matter.
A sphere is 3-dimensional.
It might help you to answer the question.
Here we go again.
Yeah, the sphere is 3-dimensional.
Yeah.
Is the surface
And the shortest
2-dimensional
distance
or
between
3-dimensional?
any 2 points on a sphere will be a straight line. Shortest distance between any 2 points will always be a straight line.
Correct.
Yeah, but it won't be on the surface of a sphere.
Well, that will be longer then, won't it? Right? And we can tell how much longer it is than the straight line, which would be the actual shortest distance between 2 points.
You said the shortest distance between 2 points on a sphere. Oh, okay, so just the 2 points are on the sphere, not the distance.
Right.
Okay.
I guess I'll say the next thing I would say anyway. The surface of the sphere is 2-dimensional because only 2 coordinates are needed to specify any point on the surface.
Oh, that's false, bro.
Really?
You're going to say 2 coordinates, but the coordinates are angles, and the angles come from the center, so you're wrong.
It's simpler than that. It's simpler than that. It's so much simpler than that. So to take 27 spheres of different sizes, right? And you had it equivalent. Yeah. Just a whole bunch of them of different sizes, right? The primary difference is their radius, right? So in order to know where you are on if you had to pick each sphere, you'd need 3 points, right? So you have to pick your sphere first and then take the radius as a given. So technically, you need 3 points.
Right, so we're just not considering the radius, I said, of a sphere. You don't need to know the radius. It's just any one sphere, not 27 spheres, just one. And you're just considering the surface of that one sphere.
That doesn't make it two-dimensional, homie.
The sphere is a three-dimensional object, but the point is, what information do you need to specify a point on the surface?
I'm guessing you'd need pi. Wouldn't you?
Right, like if you're on the surface of a plane, you might ask about the height of the plane. But if we say we don't care about the height of the plane, you only need 2 coordinates to specify the location on the plane. Does that make sense?
Would you need pi?
No, you wouldn't.
You wouldn't need pi.
No, not necessarily.
Okay, so your 2 points that you have, there is no radius and there is no relationship to pi. They're just 2 points.
None of that is needed to specify what I'm talking about.
Wow.
That's some
Well,
extra
here's the problem.
special
Here's the
powers.
problem with this. On a plane, there is no value whatsoever, right, of a differential of points in the vertical axes if you have a horizontal plane.
Well, where's the plane, right? Where is the plane?
It doesn't matter.
The plane is just a cross section of a cube in the same way that the shell is just a cross section of a sphere. I'm talking about math. If this is going way over your head, then this is why you guys are flat earthers. This is basic geometry.
Do you know the difference between the surface of a sphere and the surface of a cube?
Dude, wait a minute. Like, I'm not a flat earther, but if you think this is
the point
got
is that
something
both
related
surfaces
to
are
flat
two-dimensional
Earth, or what
objects.
anybody's belief about any of that has got anything to do with this mathematical understanding of what a fucking point is and a plane, then you've got another thing coming. I'm not a flat earther.
Yeah, I mean,
but we're talking about points and planes here.
Yeah, and the dots would be connected eventually, but you guys are just tripping at the first few steps, so it's gonna be really hard to get to the finish line.
And you're talking
we're gonna get there eventually.
That doesn't have a radius or any connection to pi.
Yep, that's right. That is what I'm talking about.
That's fantastical. It's unimaginable for most people what you're talking of there.
He's just talking about a coordinate system is all he's talking about.
That's right.
A radial coordinate system.
Radial.
A radiusless coordinate system. No radius, no diameter, no circumference. No relationship to any of them. He's just imagining something, but he's relating it to 2 points.
Well, I was going to educate him, but then he went on his little, I'm such a mathematician. You guys are flat earther retards. And so then I lost interest. It's not worth my time.
They literally go into fantasy land over a straight line. It's troubling.
Oh, yeah. Let me be pedantic to his ass real quick, though. A sphere is the two-dimensional surface of a ball in a coordinate system. The ball is the three-dimensional entity. So
I don't
eat my shorts. Well, I don't care. I'm just schooling him on his own pedantry.
Great. So that's a two-dimensional object, right?
What?
The surface, what you just described, the surface of the ball.
You opened it up for him. You gave him. Like, no, there's no such thing as a two-dimensional object. 2 dimensions does not have an existence.
Is an area, like, not two-dimensional? You know the difference between an area and a volume, right? Like an area is two-dimensional, a volume is three-dimensional, right? Is this a controversial thing around here?
Yeah, but an area of land is three-dimensional. In reality, which is where we are right now.
The surface area. Is it measured in meters squared or meters cubed?
Look, a mathematical surface is an abstract entity, not a concrete entity. Okay? That means it's not an object. Capiche?
He doesn't understand his mathematical realm that he's in. We're talking about squares. And unfortunately, for the mathematician here, squares have opposite sides parallel to each other, which obviously means
I guess my conclusion at this point is the AI is capable of following but doesn't want to, and Bev is not capable of following. So I guess I'm done.
Hi.
It is always just, this is the most shocking thing about this room, is how basic concepts that don't have anything to do with the Earth, like you said, those basic concepts end up being controversial. That is mind-blowing.
It's weird, isn't it? Straight line, who'd have thunk it? I think it's because Nathan Oakley said it's measured flat, isn't it? It's going to spark off a lot of...
Basic concepts. Basic concepts. So Bev knows the answer to this. The other guy might have an interesting answer. Okay. Can a horizontal plane exist on a globe? And by globe, I don't just mean an ideal. I mean on the Earth. Like with everything being what it is and what horizontal is what it is. Can that exist?
You're waiting for an answer. Don't think anybody's going to answer you. I'll answer you. The real globe, that's where horizontals exist. It's just things that people think in their mind. Reality is. People are unaware, right? No, yeah, I know. Wait a minute. People are unaware of the dogmatic globe that says they can't exist. And believe me, I've talked to a lot of people about level and horizontal and straight lines and stuff, and it goes to weird places. People's minds are troubled by this understanding of a straight line. But really, it's the false dichotomy that puts it out there. That's the false dichotomy that troubles people's minds.
All right, so let me get this out. So you take a level. The biggest level that I have is 8 feet long. It has bubbles on it. It has one in the center. So we're going to talk about the globe idea as if I was using this device on a globe. So what the globe tells me is that level is curved around the Earth. Okay. So if I take my level, which is a straight bar, right, milled aluminum or whatever it's made of, right, engineered to be perfectly straight, and I hold it level, then the center point is at a particular altitude. And as I go towards the extremities away from the center, the end of the level is at a different altitude than the center point. So that means that the altitude profile, according to the globe model, is that my level is actually a reciprocal slope. So the idea of a level horizontal plane existing on a globe is incoherent in itself. It literally makes no sense. Now, they then want to claim, well, level is reference to a point, right? So parallel to a plane above a given point. Now, the problem is that if you use that, in order to get that, you're going to use the quote-unquote alleged equilibrium of gravity that they claim, which is radial. And so then you'll very quickly see that those points are actually at higher altitudes. So they're not level. So the very definition of level and horizontal are incoherent on a globe. So if anything is horizontal, okay, then the Earth can't be a globe. It's that simple. Now, if you globers don't like that, I don't care. You need to make up new terms that mean something else, because those terms mean something that's incoherent and impossible on your globe. All right, they all gave up. We win.
There's no winning in this.
Yeah, an 8-foot wide level definitely proves the Earth can't be a globe. He did it.
What's that?
Yeah, I think you'd be much better off disproving the modus ponens. It's set up by one of the globe Earth gods, giants, Bob the Science Guy.
Man, why don't you just read it out then?
Modus Toilets totally dunks on modus polens every day.
Modus Poland sounds like a chicken, a fancy chicken place for college grads.
It's one of the, I mean, like I've always said that they don't have arguments, right? There's no argument that they can present for the dogmatic globe. So when he did the video, Flat Earth Logic, well impressed. But I can't give it justice. I can't, look, it's in the chat there. If you find some way of playing it on the stream, just so people can hear it. Bob does it much better than anybody else could.
No, I don't have a bot in this channel. I don't have a way to play it through my end, so I can't do it.
See whether
it's just a YouTube video or what?
It was a YouTube video, yeah. I think he's took it down, but this is just a clip from it. He talks about modus polens and modus tollens. Polens.
It's tonens.
No, it's polens. Polens. Bob,
what?
No, this is
modus. Oh, that's what he said?
Yeah, polens. Yeah.
Oh, okay.
We were in here the other day, and I think it was you, he said, that a modus polens is a way to validate and affirming the consequent, which Bob does exquisitely within his modus polens.
Yeah, it's real.
Thanks, Huey.
So the more conditions you add to an affirming the consequence,
That's not what a biconditional is.
The more valid it gets.
Basically, AI, I said that a biconditional doesn't follow the same rules of inference as a regular conditional. So an if and only if statement is different from an if only or only if statement.
Let me see. I've got it on video, so maybe I can play it. Him talking it through.
Were you trying to say that the more conditionals you have, the more likely it is to be true?
No.
Okay.
It was just trying to validate and affirming the consequent. That's what it is, really.
Well, an if and only if statement is equal on both sides, right? So if it doesn't matter which way you frame it. So when you say it's affirming the consequent, I don't really see that, right?
Here's my argument: if and only if.
Let me see if I can turn that.
That sounded good.
Yeah, right.
I just need a little more volume.
This is on my phone, and I'm going to put it at the thing so everybody can see. I've put it in the text chat here, so you can get this for yourself. So it is in the Discord, but this is what it is. Here we go.
Let's go ahead and have a look at an example that I've been using a lot of lately. Here's my argument: if and only if the Earth is a sphere, P, the shortest distance between any 2 points in any direction will be a great circle distance. Q, the shortest distance between any 2 points on Earth is a great circle distance. Therefore, the Earth is a sphere. This is an example of a modus tollens argument. Now, the flat Earth could use a modus tollens argument to disprove this by demonstrating that the shortest distance between any 2 points on the surface of the Earth is a straight line. In other words, a non-great circle distance. So their work is cut out for them. This is Bob the Science Guy signing out from Northern Michigan. Thank you again for stopping by my channel. I really appreciate your support.
Okay, no one ever said Bob the Science Guy was a great logician, right? But you could easily rework that into
he's one of the globe Earth shadow giant greats. Living shadow giant.
You can easily amend that whole argument. It's not too difficult.
No, he's put
they're claiming victory because he didn't include the
well.
words across the surface. Like, all you have to do is say across the surface, and that's it. Done.
No. He said all you have to do is measure a straight line between any 2 points.
Yeah, but we talked about this yesterday, Bev. Steelman, think of the best possible way you could have interpreted that argument.
Well, we've been talking about it all morning, measuring the straight line from the baseline. It's a necessity for establishing that baseline for any structure of measurement. They'll be related to that straight line.
Maybe we can start off even simpler. You would agree that a line is a one-dimensional object, or is that controversial too?
It's not an object, is it? I mean, how can you objectify something one-dimensional?
What is it you think you're measuring?
It's a distance.
Yeah, and that distance is a distance of what?
A unit, a relationship to a unit, a straight line.
Yeah, a line. Which is one-dimensional.
Yeah, but not an object.
Okay, well, I'll leave off the word object. A line is one-dimensional. Is that controversial?
Genius. Length without breadth.
Right.
I think so.
And the units are always meters. It's never meters squared or meters cubed, or inches, not inches squared or inches cubed. Yeah. The power is always one. It's not squared or cubed. Length is a one-dimensional measurement in contrast to area, which is two-dimensional, in contrast to volume, which is three-dimensional. I hope none of that's controversial. You following me so far, Bev?
Yes, the sphere is 3D, the square is 2D, and the distance is 1D. It increases by these straight lines.
Okay. Now, on the straight line, you only need one piece of information to tell you where you are on that straight line.
No,
that's another equivalent.
And an end point for the straight line, and if you want to say where you are, then you're going to need a relationship to either one of those points, aren't you? Preferably both.
Yes, so you can't do it with just one piece of information.
If you have a point on the real number line, you only need one number to tell you where you are. It doesn't matter where 0 is.
Talking about setting up
those
the
points.
line.
Those points. Hold on. Those points are named.
The line's already been established.
Yep, exactly. So the points are named and the origin is named. Right?
His framework. We're talking about the framework, but you've already got it established. It's already there as a given. Maybe why we're talking at cross purposes here.
Yeah, no problem. Let's work it out so we can understand. Take a graph, a standard graph with a zero origin and your positive numbers, your negative numbers on the x and y axis. Now take all the numbers off. Now take all the grid lines off. Now tell me where you are on that line with one piece of information. Good luck.
Yeah, take the piece of paper off too.
Yeah, just 2 points.
I mean, you're fair to have the black line,
So do you think anyone will be attempting to rebut Bob's argument, or are you all just happy with Bob didn't actually say the right argument? He actually meant to say something other than he did say. Because that's all I've ever heard, really.
I don't think it goes without saying that animal behaviors are essentially immoral, even if they.
Thanks for that non sequitur.
Animals are immoral. That's why I eat them as punishment. All right, moving on.
Yeah, I don't think there is any rebuttal to Bob's, I find it weird that because he offers the flat earthers a chance. Has anybody took it up? And
a chance for what?
How would you? Well, is that what I'm saying? Is that what Nathan Oakley's building up to? Because, like he says, the straight line being the shortest distance between 2 points would be the modus tollens to his argument. It would invalidate his statement that the Earth is a sphere. But he says you've got your work cut out for you. But Nathan Oakley's going ahead with the Earth is measured flat. So, I mean, that measurement would be a straight line, wouldn't it?
Yeah, flat would be straight.
Also in the vertical, like that straight line measurement distance. Any straight line measurement distance in any direction would invalidate Bob's modus tollens.
Oh yeah, but you also got to keep in mind I mean, not saying there's not other evidence presented as well, but he hasn't validated his conditionals anyway.
Yeah, you don't want to be getting people in the same state of mind as Bob, really, do you? By inviting them in to this arena to imagine that, this argument from Bob is just about the only argument the Globe's ever made. And it's, as you can see, it's got, well, he has took it down, but isn't it worth,
why did he take it down?
Rebutting? I know, why would he take it down? He did a whole video titled Flat Earth Logic, where he explains it, and this is one of his arguments that he's been using. Now, not only Bob, there's a lot of people that are using this argument, like they've developed it for themselves. And I think when I came into this arena and I said level is a straight line on a horizontal plane, right? The deep-rooted idea of this, that's what they were threatened by, the straight line. So they mistaked me as being a flat earther because I was talking about a straight line. It's been going on for years.
I'm not a flat earther.
No, I'm not a flat earther. I can measure the Earth not flat. But I've been in an arena where there's a lot of flat earthers, so I sort of feel.
Yep. Perfect. So when people say they're a flat earther, do you think that they mean that the Earth is smooth?
No, I think what they mean is that level is a straight line on a horizontal plane. They just mistakenly call themselves flat earthers because of that. I don't know. Robotham, I think, is the one to blame, really.
Right. So if you have a horizontally arranged Earth, right? Generally, with variations on the surface, which if you took the whole mean and took it as a general, and you said, oh, it's arranged horizontally or oriented horizontally,
mean Earth
then you look in the
flatness.
dictionary. Right, and then you look in the dictionary, and in common parlance, the term flat also means arranged horizontally or laying horizontal. Then to describe the Earth as flat, when you're not meaning smooth, is quite adequate.
Yeah, well, here's the thing, right, that I find a little bit strange. That both the sea level, the mean sea level, and the mean Earth flatness, both of those would be measured on the vertical. And most surveyors that I've talked to, they call it vertical because that's how they measure it. That's how they see it, on the vertical. And I would agree with them because that is what you see. You see the guy with the measuring rod. You measure this on the vertical. You take all of those measurements, and if you want to find a mean, you divide them by however many times you took the measurement, and there you go. Boom, mathematical mean. It's a point on a vertical datum.
Yeah, and what orientation is that datum reference to?
It's on the vertical. It's the vertical datum.
Dude, if you have nothing but a vertical, right, then you wouldn't have topography. You'd have incremental arrays.
It's literally called the vertical datum. NAVD is the North American vertical datum.
Each vertical ray to the point is based off of what?
Okay, very argumentative.
Well, look, if you have a bunch of vertical data, right, and you put that in a graph, it would be a straight line going straight up on the y-axis. What use would that be to anyone?
Well, if you've
it
got
has
an
to be
equal,
correlated to something else.
I'd say that on the Z. You mean you have to have an equal XY position in order to have that?
Yes, each vertical is over a horizontal plot, right?
Yeah, each vertical is established independently at the position wherever you are. But you're talking about the points on the vertical datum or on the horizontal datum, like one or the other. Which one?
Dude, the verticals would be meaningless.
What vertical would be meaningless? No, the vertical would be the Z. The elevation change. It's not meaningless. It's measured.
Okay, there you go. So elevation from what?
Well, you establish a mean, don't you? Like we say, the sea level at a point. Sea level goes up and down. You establish a mean on that vertical datum, right there where you establish the mean. You then transfer the data from that as the zero to another point.
Right, so the tool that they use measuring a point on a vertical line straight where they set up the tool, straight up into the sky. In other words, a point altitude over their position. Yes or no? The answer is no.
Okay, well done. Point altitude, did you say?
So their stuff is meaningless without the horizontal base. It's absolutely meaningless.
Well, we use the horizontal, the tool that establishes horizontals to transfer those points on the vertical datum from one point to another. Yes, we measure it so. Which is why I'm confused about Nathan Oakley when he's measuring the Earth flat, because I don't see how a measurement on the vertical can help measure the Earth flat. But I mean, that's not for you guys. He's going to come over here and, you know, tell you about his plan moving forward. Convincing yourself through belief. Just say it confidently. You'll be right. We can get through this.
His whole point is that a measurement on the vertical, if it's an altitude angle, necessarily has a contingent necessity of a horizontal plane in the first instance in order to get that. So if that's true, then he would be correct.
Yeah, I'm saying, like, I'm giving one of you guys, because Bob offers it to flat earthers, right? So it's only right that a flat earther offers this to Nathan Oakley as measuring the Earth flat by measuring the shortest distance between 2 points as being a straight line. Like Bob says, the modus tollens to his modus ponens. He could therefore set up a false dichotomy, already done, prove the Earth's not a sphere, say, hey presto, the Earth is flat.
Bro, who cares? Nathan Oakley is not the pinnacle of the flat earth to which all things must be vetted and given to him in order to be promulgated.
Yeah, but that's his confidence going forward, right? He's going to be way more confident than you are. Do you not want to ride that train?
What?
He's taking it places.
No, dude, I'm not riding anybody's train. That sounds pretty gross.
Just trying to help out.
Guys, I work for NASA.
Actually, it sounds more like you're characterizing us in a very bad light, like our motivations, or the way we think, the way we, celebritize people, all these types of things. That's what it sounds like. Now, whether that's your intention or not, it's kind of off-putting.
You sound like a big voice.
It's kind of like when people come in here and they say, "Oh, you're a QE flat earther because you say things that QE says," or all that stuff. Like, oh, that's nonsense. Arguments stand or fall on the merits of the argument.
And the definitions of the words within the arguments, obviously.
Well, yeah, that's crucial. It's like one of the biggest ones that we suffered in the early days was I'm not saying we suffered it, but the Globers and the flat earthers, they were always using the term gravity. And then they never would parse out that when Glober says down, he doesn't mean down, he means inward, right? The Glober's entire way things move is inwards. And if you're a flat earther or a horizontal earther or a parallel earther, whatever you want to call yourself, down is simply down. Down is truly down. But on a globe Earth, what we experience as down is actually inwards. So it's the same word, down, both people use, but they mean two different things.
All right, guys. I work for NASA. Okay. With the wealth of data and observations we've gathered from our space missions, satellites, technological advancements, I can confirm with absolute certainty that the Earth is an oblate spheroid. Okay.
What about the shortest distance between 2 points being a straight line?
Buddy, I've seen it. I've seen it with my own eyes, buddy.
So that is a straight line then?
No.
It's not a straight line. The shortest distance between 2 points. Is it a straight line or isn't it?
Buddy. I'll take you on a mission with me, okay? And we can look at it together.
I'm trying to work out whether you're a higher ranking officer than Bob the Science Guy. Because Bob the Science Guy's made an argument that says if the shortest distance between 2 points is a straight line, then the Earth's not a sphere. Rather a weird argument, but yeah, he made it. So what does NASA think about that?
NASA thinks you should open a textbook and start reading.
Mm-hmm. Well,
is there a textbook that says the shortest distance between 2 points isn't a straight line?
The sacred text.
Has to be.
There will be in a couple of years.
Yeah, that's literally what we're doing here. The modern sophistry. It was wrote out. The very guy that they call the shortest distance about, you might have heard of him, Max Planck. So yeah, I've got a little saying that he said, but that's what we're doing here. Well, my thing's gone. I posted it earlier. There we go. Post it again in the chat. A new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation grows up that is familiar with it.
Yeah.
Education. Shadow giants. That's what they're doing here. They're just projecting shadows for you to imagine. Straight lines. Can you imagine a straight line being something other than what you imagine a straight line to be?
No.
Can you imagine somebody else doesn't understand, have a similar understanding than you of a straight line?
Oh, yeah. Yeah. I've heard enough people talking to know that some people don't understand what a straight line is. Hey, you want to know a good one?
Do you imagine that they think differently about you, though, right? Because they have their understanding of a straight line. And you say that their understanding of a straight line is different, so therefore they have a different understanding. But their understanding of a straight line is the straight line. Gets your head wrapped up in weird places once you start to contemplate this. It's particularly if you're coming at it with a already preconceived model that you have to fit to this understanding of a straight line.
Well, I mean, that's why they call it a non-Euclidean geometry.
Because Euclidean geometry is the straight line that you understand of squares and triangles. Just not that, right? Not that straight line. Something different. Which these guys can have that concept of because they've been taught the ability to. Their minds can go to the place where it's sort of the same but different. Both. It's been taught since the 70s, diletheism.
Yeah. The parallel lines, right? So parallel lines are defined that they never meet, but in the other quote unquote geometry, they meet.
No, there are no parallel lines. Because the definition of parallel lines.
Hold on right there. So let's say, well, that is true in that, but
there's a definition of parallel lines. They're not getting rid of a definition.
Right, but we got to parse this out. In that system, are the proponents taught there's no parallel lines, or are they taught that parallel lines will meet?
In that axiomatic system, the definition comes before the axioms and postulates. So therefore, the definition is unchanged. A parallel line is two straight lines on the same plane that, if extended, never meet. Right? That's the definition of parallel lines. You can't get rid of it. It's already there.
Okay, so then where did all those guys who come in here for the past years that say in non-Euclidean geometry parallel lines can meet, where'd they get that idea from?
Fight the Flat Earth said it. He said
There's
it
tons
in a
of people
debate
that
with
said
me. I think it was over at 24/7. Like the Flat Earth exposed the entirety of the globe mind. If people didn't see it, then they didn't see it. But yeah, Fight the Flat Earth gave them a chance to imagine that level being a straight line on a horizontal plane was somehow wrong and falsified by stating and shouting non-Euclidean geometry.
Well, I mean, I can just look up. I just looked it up, and like all these top search results mention within their blurbs, without actually going in, like the first blurb, straight lines that are parallel can meet at the poles.
Well, it's not a straight
line, right?
Then,
so implicit in that is parallel lines meet.
Yeah, no, that's not within geometry.
Right. So let's change the word non-Euclidean to geometry to non-geometry. There you go. Problem solved.
Yeah, no, there's no straight line. It's not Euclidean. And Euclidean is everything that you use to understand everything around you. That you use that reasoning process, that logical framework of if this, then this. That structure. That's Euclidean. You define all of your terms beforehand, and then you go through the axioms and the postulates, and then you go to the propositions, the proofs, and you lay them one on top of the other, and then, and just keep going. That's geometry that we all use in reality. The straight line.
Hey, listen to this one. Do we live in non-Euclidean geometry? Indeed. Although our experiences seem to match Euclidean geometry, we cannot really be sure that our universe is Euclidean. In other words, we can't be sure that parallel lines are parallel.
Yeah, it's a bad state to put your mind. Because the opposite is, right, if you take this model to a full affliction state, they'll literally tell you have to axiomate there being no parallel lines. Which, I don't know what that does to a square. Unless, right, this, since the 70s, bringing this diletheism in, where you can have two truths. People stop having the ability to see the contradiction because they allow it. They've axiomated allowing a contradiction within their logical structure, and that breaks minds. Literally.
Okay, so a square, what kind of shape is a square?
It's a square.
No.
Yes.
It's under a subheading.
No.
Yes, but it's under
like
a subheading.
That thing that you picture in your mind, right? It's a square.
Okay, this isn't a trick question. I'll just give you the answer. A parallelogram.
Yes, it's opposite sides of parallel. That's why I'm saying it. What do you do to a square if you axiomate there being no parallel lines? What happens? What does your mind do?
Well, what did that girl just say? Well, I don't know. I just imagined it was a girl that wrote this because that was the voice in my head when I was reading it. But they just said we can't be sure we live in Euclidean reality. But a square is a parallelogram, so that means squares don't exist. If we're in a non-Euclidean reality, then squares wouldn't exist. Makes no sense.
Logic.
Same with the horizontal, right? A horizontal line or a horizontal plane would be a reciprocal slope or a pyramid if the Earth was a globe. It's literally incoherent. Like it's literally a paradox. Or maybe paradox is too weak of a term.
If in reality the shortest distance between 2 points was true, then triangles would have 180 degrees in reality, because the mathematical structure of our understanding of triangles and the likes of sine and cosine, pi and all of that, then that would be true in reality also. Can you imagine something different? Because that's where non-Euclidean geometry and this stuff exists. But like the flat earth's told him, he can have it. Bob the science guy is so confident that the shortest distance between 2 points in any direction isn't a straight line. He's offered his model up, sacrificed to the false dichotomy. Confidently. He says it confidently. All you've got to do is say it confidently. And this could be a proof. But like we had in here the other day, they said, you know, you can't have the shortest distance between 2 points. This is modern science. I think that you were your speaking experts the other day telling us that.
Who was?
I don't know. It was some, you know, like you have the guys who do the speaking for the room. One of those. Might have been Peter.
They say. Oh, okay. You see, the problem about these non-geometries is that you always have three-dimensional free space, right, to navigate. So you're not limited in your course, right?
But I don't know. I
And
think
it's
the
like
non-geometries are meaningless if you don't actually know the sort of meta behind the geometry that they're the none of.
Oh, sure.
Like, it's no good knowing the not that without actually knowing the that, right? In order for you to say not that, you must require a that. Like saying not that to a nothing with no that is meaningless. So that's why I say you should really have your proof sorted, your base. You should have your foundation sorted, that you can have something there in that position as that's solid, that you can refer back to. That's like sort of the journey that we've been on here. And it's really weird because you go backwards all the time. And people keep driving you backwards because they keep telling you you don't understand it.
Hey, speaking of backwards, so really back early in the day, this has nothing to do with backwards argument, just something that happened in the past. There was this guy, he went by a YouTube handle, Curious Life of a Flat Earther. and he was talking a lot about the horizon. He started talking about the etymology of the word that's used for horizon in different languages. And he got to like some Arabic language, and he's like, one of the oldest languages, and the word for horizon roughly means man's mental leveling. Think about that. Like it's the horizon is your mental appraisal of level.
Antonio? Okay.
That's right. You're hot making it. Buddy. Unless you want to ask a question. Professor Bill. All right, time's
Yeah,
up.
I'm in like row A6 or some shit. Yeah. I'm in A6, I think. Gotcha.
Oh, well, I just muted that guy. If you want to be unmuted, let us know when you have control of your mic. Oh, man, I'm getting tired.
Sorry, I had to leave. Tend to the missus. I'm gonna have to get off, guys. It's been interesting again this morning. Don't know what we established, but I'm pretty sure I learned a lot.
We established that it's okay for flat earthers to call themselves flat earthers. There we go.
Yeah, people can call themselves whatever they want. Like there's literally a way now to measure the earth flat. Dead easy. False dichotomy for the win. See you later, guys. Thanks a lot.